حاجه اسمها الفورسنج تيرم. مين اللي بيحرك الدومين؟ ممكن يكون الويند. فورسنج تيرم بقى كتير قوي. ممكن يكون الووتر ليفل، يعني انا الويند هي اللي حركت. فاكرين مساله الويند؟ ممكن يكون في سورس، حد بيرمي ميه في الحته دي، يبقى دي اللي بتحرك، ده اسمه فورسنج تيرم. ممكن يكون الباوندري كونديشن، ان انا جيت على الباوندري وحطيت مستوى تايدز بتطلع وبينزل، يبقى ده اسمه فورسنج تيرم. فانا عندي فورسنج تيرمز كتيره. اوكي، حسب انت ايه الدومينانت. ممكن يكون الويفز، يعني يكون اصلا انا هحل مساله انا مش مهم يعني فورسنج تيرم ممكن كذا حاجه في وقت واحد، بس مثلا ممكن انا مش هحط في مخي التايد، بس عندي ويفز شغاله. فالويفز دي بتعمل كرنتس، بتعمل حاجه اسمها الويف انديوزد كرنتس. يبقى الفورسنج تيرم ساعتها فيها هو الويفز. تروح تحل ويفز، تجيب من الويفز حاجه اسمها الراديشن ستريس كومبوننتس، تدخلها هنا تعمل لك كرنت هنا. اوكي؟ ف طبعا تغير في البريشر وتحديدا الدنسيتي نتيجه الملح والتمبريتشر السالت والتمبريتشر ريليشن are considered as a subordinary to the hydrodynamic module and are set up here. يعني لو انت عندك تغيرات في نتيجه التمبريتشر ونتيجه طيب بعد كده السوليوشن تكنيك اللي تم اختياره هو لو اوردر فاست الجوريزم. لو اوردر فاست الجوريزم والسبيكس بتاعته اختار المينيموم تايم ستيب من 1 من 100 ل 30. هنا بيقول لك ايه؟ بيقول لك the simulation time and accuracy can be controlled by specifying the order of the numerical schemes. يعني ايه numerical schemes؟ هو وان كان لما بنيجي نعمل يعني مش عارف المعادله بتاعتي بيسموها ديفرنشال ايكويشن. فالديفرنشال ايكويشن يعني كمثال احنا طبعا علينا المعادلات اللي شفناها مع بعض. فلما بيجي يقول لك ايه دي اتش باي دي اكس دي تي، فدي معدل تغير الدبس او الووتر كرم بالنسبه للزمن. فدي يجوا بتوع السكراتيزيشن يقول لك ايه؟ انت عايز تحولها لي بقى المعادلات عاديه. فيقول لي ايه؟ يشيل دي ويحطها. فممكن يقول لك ايه؟ دي عباره عن اتش عن تي بلس 1، يعني اتش بعد زمن اتش بعد زمن تي بلس 1 او تي 2 اتش 2 عند تايم بيساوي 2 ناقص اتش عند تايم بيساوي 1 على دلتا تي. يقول لك دي اتش المستقبليه، يعني اتش الحاليه اسمها على الزمن. هو ده بيسموه لينيرايز، ده ابسط حاجه. ده اللو اوردر اللي هو بنسميه هنا لو اوردر. في بقى ايه؟ هاير اوردر. هاير اوردر بقى يقول لك ايه؟ مش اتش بقى عندي، يقول لك ده انا عندي اتش عند تي بتساوي 3 ناقص 2 اتش عند تي 2 مثلا اتش عند تي بتساوي 2 زائد يديك اكسبريشن على دلتا تي، مش يديك اكسبريشن اقوى اعنف. اوكي؟ اللي هي مثلا يعني ايه؟ هنا في ديسكريتايزيشن كتير في النيوميريكال اناليسيس، بس احنا مش مصدر ان احنا نتكلم عليه، بس الكونسبت. فده بيسموه التايم كان التايم سكيم، صح؟ انتجريشن. وفي السبيس ديسكريتايزيشن. ده الديسكريتايزيشن في السبيس برضه تشتغل بهاي اوردر ولا بلو اوردر؟
ده بيأثر على
الاكيو طبعا. ران تايم كتير جدا.
يعني اشتغل
انا الضابطين كله على الاوردر. لا، انت في بعض المسائل المعقده جدا، يعني في بعض المسائل المعقده بتحتاج بقى يشتغل في الهاي. لكن هنا السيتنج بتاعنا اللو اوردر. فهنا بيقول the simulation time and accuracy can be controlled by specifying the order of the numerical schemes that are used in the numerical calculations. Both the scheme for time integration and for space discretization can be specified. you can select either low order scheme اللي هو الفيرست اوردر بسيط قوي or higher order schemes. The low order scheme is faster but less accurate. هو اسرع بس الاكيوريسي بتاعته ايه؟ اقل. تتغلب على الاكيوريسي ازاي؟ ها؟ لا اكيوريسي الماني ده مش سايز المش سايز. فلو المش سايز بتاعتك صغير خلاص خد اوردر عادي شغال. اوكي؟ To control the time step, it's also possible for the user to specify a minimum time step and a maximum time step. هو البرنامج من جوه بيقدر يكنترول موضوع لو ما عملتش كونفرجنس على النتيجه الكبيره اللي انت حاططها له فبيعمل صب يشتغل على الداتا دي اقل منها يظبط نفسه بس انت بتديله منطقه يشتغل فيها. فانا لما بقول له من كذا لكذا فهو بيقعد يظبط نفسه ويلعب بحيث ان هو يظبط نفسه يستابلايز. والله ما قدرش هيضرب. يعني هو بيتعب معاك شويه لكن في حدود اللي انت قايله عنه. هو بيحل الكبيره جابت يسلم ما جابتش يقوم يظبط. دي اوتوميتد داخليه. فاهماني؟ طيب انا طبعا عندي لو اوردر هاي اوردر وعندي حاجه اسمها ديبس كوركشن. لو انت حضرتك عايز it's possible to define correction delta z to the defined mesh bathymetry to be included in the simulations. If included in the simulation, a data file with the depth correction values must be specified. يعني انت ممكن انت حافظ الدبس، انت ممكن تغير الدبس زي ما انت عايز في المش جنريت، بس اقدر انا حليه وعايز العب في المش دي از كاليبريشن بارامتر. فمش عايز اعمل كل حاجه من جديد، فعايز اضيفها جديد. فما قال له يا عم هعمل ديبس كوركشن. يقول لي ايه؟ اقول له حط لي متر زياده، اطرح لي متر. شوف الدبس اللي اصلا عايز اشوف السنسيتيفيتي بتاعت الدبس. هل بتاثر؟ الباتيمتر ازوده كله متر كتير متر خليها 1 سم. فاطمه بقول لك ايه انت لسه جايه وما مش عارفه هو صح ان الحمد لله سلام نوتينا طلعنا سعيدين هو الباتيمتري جاي اوكي بس هو يعني احنا بيبقى مش الوضع ده بتاع البحر بينزل ويطلع يعني الدنيا ما هيش ايه ما فيش حاجه مكتوب عليها اللي هي عظيم يعني. فهو الراجل بيديك الاوبشن ان انت وعلى فكره مش هو بس كل الناس بتشتغل على التسجيل هتلاقيه برضه عنده الباتيمات هو عنده الاوبشن بتاع انك انت تقول له شيفت الباتيمات كله متر فوق اي كان اوبشن
بس كله يا دكتور مش اوبشن ان انا اعمل
لا هنا بقى في سبيسيفايد بيد ليفل 10. يعني في هنا انا عندي الاوبشن هنا يا شباب ان انا لا اقول له سبيسيفايد. بصوا هو مديني اهو بين بلا 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 ديبس كوركشن ديبس هنا هو بيقول له نو ديبس هنا سبيسيفايد تشينج. وجيت بقى في السبيسيفايد بص كده تلاقيه يقول لك ايه عايزه فارينج ولا كونستانت. واخد بالك ده كمان ايه ده بيقول لك فارينج ان سبيس وكونستانت تايم لا فارينج تايم اند دومين. واو يعني حاجه بقى يعني ما ازاي ده بيحصل في الحياه مش مهم. هقول لك يعني قصدي بقى الاختراعات. يعني تخيل الدبس كمان قاعد يتغير معاك هتقول لي ازاي واحد حب في دماغه يعمل تجربه في المعمل ويكون الدبس البيد بتاعه اصلا بيشغله لي موتور تاني. فهو بيكبر هو قاعد بقى يكبر معلش بس مش فارق بالنسبه له هو في الاخر ده رقم مع الخطوط وهو اللي بيقول لي كل شويه. فهو لما عمل فهجيب حاجات كتير فور ريسيرش. انما هو الطبيعي ان احنا مش هنستخدم الدبس كوركشن. لو انت عايز تستخدمه في الكاليبريشن بروسيس ماشي اوكي. يعني انت لو عايز تلعب في الدبس من غير ما تلعب في المش اصل هي الفكره ايه ما انت ممكن تروح تعمل مش جديده بالدبس الجديد بتاعك. طب افضل لا انا عايز المش بتاعتي تبقى اساسيه بس عايز العب في الدبس ككاليبريشن بارامترز ودي عاده بتبقى في اماكن محدده ماينور بتبقى فيري كريتيكال. واخدين بالكم؟ فانا مثلا بحل مساله كبيره قوي
في جزء مثلا.
في لا خاصه في الشانلز حتت ضيقه. الحتت الضيقه دي الدبس بيبقى فيري سنسيتيف لانه بيعكس جماعه الكرنس كده. فانت ممكن يعني في تشانل لو حضرتك عمقت التشانل خلاص تنزل. اوكي؟ فانت عايز تلعب في التشانل بس مش عايز تعمل البيش كلها من جديد، فانت تقدر تغير ده از كاليبريشن بارامتر. اوكي؟ فاهمني؟ طبعا انت لو دخلت فيه كده هتدخل الملف بقى. يقول لك طب فين الملف بقى اللي انت هتدخله؟ فانت تبقى مجهز ملف بالدبس ديفرنس. اوكي؟ اللي هو الدبس افكت بس اللي هو هيبقى زي المش بالظبط. اكن يعني في ملف مش بس هعمل ملف تاني في الديفرنس.
يعني مثلا لو منطقه انا عملت فيها تكريم.
ايوه.
الحته دي لوكالي الجزء بتاعها.
جميل. ده مثال حلو قوي. اتفضل.
الجزء ده اللي انا هعمل له فايل بالديفرنس.
ايوه بالظبط.
بس يكون في التوتال هو مش مكتوب هنا.
بالظبط. يعني انا في التكريك عندي تو اوبشنز. اما اعمل ملفين، واحد قبل التكريك وواحد بعد التكريك لكل دومين. واحد تاني يقول لي لا انا هعمل واحد بيسك وحضرتك عملت تكريك بمتر، يبقى هعمل واحد تكريك متر ديفرنس وواحد تكريك مترين، واحد سيناريوز مختلف. وبالتالي مره اختار ده مره اختار ده، لكن البيزك بتاعي نفس الشيء.
نوع الفايل
قول.
نوع الفايل
دي اف اس يو اللي هو المش العاديه، بس تحط فيه تكريك بس. تغير الدبس تكريك بس، يعني كله يبقى زيرو ما عدا الحته اللي انت كررت فيها منه. اوكي؟ نرجع مرجوعنا. طيب قلنا هنا varying with time varying with space والاوبشنز بتاعتها. the file must be بيسموه the file must be 2D unstructured اللي هو دي اف سي يو.
معلش الحته اللي فاتت.
ايوه.
اما اجي اعمل تكريم احط له بقى في الدبس فايل ده بالماينس.
على حسب النوتيشن بتاع كل برنامج. هل النوتيشن بالماينس؟ هنا الدبس بتاعنا بالماينس، انما اظن الدلتا بيبقى بالبوزيتيف. ماينس برضه في الار اللي هي
شغال ويب
على حسب شغال.
يعني كل برنامج على حسب النوتيشن بتاعه. ازاي؟
هنا هنزل يبقى ماينس، بطلع يبقى
بوزيتيف بالظبط. اوكي؟ فانت لو بتتعامل مع برنامج لازم تاخد بالك من النوتيشن بتاعه. هو واخد زد ابورد ولا دبس. اوكي؟ هنا بيقول the flood model and dry can be specified in two different ways. هنا flood and dry عملنا كوريكشن يبقى بنتكلم عن flood and dry. فكنا اتكلمنا عن هنا كان بنتكلم عن flood and dry. The flood and dry can be specified in two different ways. No flood and dry, flood and dry. لو ما فيش flood وخلاص ما فيش flood فانت هتشيل الاليمنت ده بقى طول الوقت مش هيخش معاك، وده اسرع بكتير في الكتابه. اسرع بكتير قوي. او لازم بقى flood and dry. If your model is located in an area where flooding and drying occur inland حته كده يعني، فانت ساعتها you must enable the flood and dry facility and by selecting flood and dry. In this case you have to specify a drying water depth and wetting depth. امتى تكون مبلول وامتى تكون ناشف. انت تحدد. هو حضرتك الريكومنديشن بتاعك. بس انا واحد عايز يعمل بحث في هذا الموضوع. اوكي؟ فيقعد بقى يلعب مش عارف ايه، بس من الخبره لو دول قربوا من بعض بيحصل انستابيليتي. فعاده بنبعدهم عن بعض. واخدين بالكم؟ فنحط واحد مثلا 1 سم والثاني 20 سم، يبقى في فرق ما بينهم عشان الموديل ما يخشش في انستابيليتي بوينت. اوكي؟ when the water depth is less than the wetting depth, when the water depth is less than the wetting depth, the problem is reformulated, and only if the water depth is less than the drying depth, the element cell is removed. يعني الاليمنت هيدخل ولا هيطلع لو الميه the water depth is less than the drying depth. انت بتقول له النشف بتاعي متر والدبس نص متر، يبقى دي بلد. اوكي؟ يعني هي الموضوع ببساطه من غير ما نخش في الارقام. الاليمنت هيدخل ولا يطلع على حسب انت حاطط له ليميتس. بتقول له ما بين دي ودي اللي فوق ده مبلول واللي تحت ده ناشف، طب اللي في النص هو هيتعامل مع حاجه كده يعني ايه؟ يعني سن ازاي هنا الديفلوبر بقى ابتدى يدخل دماغه في حتت ما توجعش دماغك فيها. اوكي؟ يعني اللي هنتفق عليه ان عندي اثنين ديبس، هم عندك كام؟ اللي هم 0.005 متر وال 0.1 متر. هو حاطط هنا كام؟ 5 مللي و10 سم.
اه
يعني بص هو حاطط اثنين ديبس، واحد 5 مللي وواحد 0.1 متر. انتوا يجي يقول ايه؟ يقول لك ده الدراي ديبس وده ويتنج ديبس، صح؟ فلو انت 5 مللي يبقى انت ناشف خلاص، يبقى ده لاند وده سي اللي هو الويت. لو الدبس عمود الميه،
بيت المية مش ارتفاع
هو الدبس اللي هو ارتفاع عمود الميه من الارض، ارتفاع عمود الميه من الارض. اوكي؟ لو بقى 0.1 متر يبقى دخلها في بعض، ده كان النود دي معايا، يبقى دي نود فيها ميه ودخلها في الانسان مثلا. طب لو هي 5 مللي طلعها من الانسان ما فيهاش ميه، ما عندهاش ايه مش داخله مش شايف. اوكي؟ يبقى ده هيخش ده هيطلع ان في مالهاش دعوه. اوكي؟ فاهمين؟
كده اكشن ده حصل يعني.
بعيدا عن القراءات،
يعني
يعني لو الميه وانا بحسبها طلعت 0.1 متر
كده حصل لها.
يبقى دي نقطه فيها ميه وتخش في الحسابات المره الجايه. طب لو انا حسبت وطلعت 5 مللي يبقى دي ما فيهاش ميه، مش هتخش في حسابات المره الجايه. اوكي؟ قول تاني. ده ست ده ست
يعني ايه النقطه اللي هو بيختار منها الارض والبحر؟
بالظبط كده. يعني انا دلوقتي انا عندي مش انا كان عندي خط الارض عامل كده مثلا. احنا بنتكلم على ال ال الميه
لبس الووتر.
الووتر. اوكي؟
احنا بنروح الرن نقول له يعني اعمل رن للويت اريا، فهو بيعمل
ويت اريا
هو بيختار ويت اريا من الاثنين دول بس. الاريا بتاعهم.
يعني هنا في ايلمنتس طبعا انا هعملها مربعات بس يعني هي مش مربعات. الميه كانت ماشي. بصيت انا للسيرفس اليفيشن او ارتفاع الميه هنا كام؟ فلقيته واحد كده. يبقى دي ميه ولا مش ميه؟ ميه. جيت احسب عند النقطه دي، فجيت عند النقطه دي 5 سم. ارتفاع الميه هنا 5 سم. 5 سم خليها 15 سم. يبقى دي ميه. جيت احسب عند النقطه دي طلعت 0.0001. يبقى دي لاند، يبقى مش داخله معايا، اكيد مش يبقى دي طلعت من النص بتاعها.
البرامتر كلها بتكتب على
البارامتر بس على النت، الدراي مش اكيد مش شايف. لكن بعد شويه الواحد متر دخل كبس على البتاع، فبقت دي 1 متر وبالتالي دي بقت 10 سم. يبقى خش معاك دلتا، كل دلتا دي بتتكتب. مش انا بشتغل بدلتا 30 ثانيه، كل 30 ثانيه اعمل تشيك مين ويت مين دراي. قبل ما احسب معايا اسماء ممكن تطلع اتفضل. لا بس يعني انا بس لا 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 انت شايف عادي ده. بقول لك ايه انا اقول لك
هو المره اللي فاتت يعني مثلا لو كيس يعني احنا عندنا رينج دلوقتي بين السي وبين اللام.
ايوه
لو اي حاجه اقل من اللام فهو خلاص هيكسب بين النقطه دي الرينج مش هيبدا يحسب اي حسابات.
مظبوط.
ان بتوين هيبدا أنا عندي كيميكال ايكويشنز يعني الماس فلكس والمومنتم فلكس هيبدا يشغل ان بتوين هشغل الماس فلكس ايكويشنز. بعد كده بقى من السي دخل لحد الاوف شور هيدخل التو ايكويشنز بتاعت الماس فلكس والنافيرس فلكس ايكويشن يعني
هو فهمت حاجه؟ اه ممتاز. فيعني اصل هو بقى عندنا تو ايكويشنز المفروض تحققهم. فهو في الكونتينيوتي كميه الميه لازم احافظ عليها ودي بيسموها الكونتينيوتي. اوكي دي كميه الميه فما ينفعش الميه نبتدي في الدومين بميه وانا اقفل الدومين كله. خليني اقفل الدومين عشان ايه؟ بقفل الدومين ابتدي بميه 1000 متر مكعب وسط الرن يبقى 500 متر مكعب. ده بيحصل ليكي من غير ما اكون انا حاطط ليكي ولا يعني فما ينفعش. فده بيسموه كونتينيوتي ايكويشن اللي هو الماس كونسرفيشن. الماس كونسرفيشن. اوكي فهو لما تبقى ان بتوين في شويه ميه داخلين في اللعبه دي صح هو بيحافظ عليها. لكن ايه الدراي جار بيحطهم فين بقى هو بيورك كمان. فعشان كده اللي هنا سالك واللي هنا سالك واللي هنا بس انت تبقى فاهم يعني ايه دراي يعني ايه. فهمتوني يا شباب؟ هنا بيقول بقى هنا ايه والله بقى القصه اللي كان بيحكيها الراجل ده هنا بقى بيحكي بيقول لك لو هو درايف از ريموف فروم سيميوليشن. هنا بقى الجمله الاخرانيه اللي هي بقى كان بيتكلم فيها احمد the formulation is made by setting the momentum fluxes to zero and only taking the mass flux into consideration. يعني هو بقى لما بيجي يحل بيدخل الكونتينيو الماس المومنتم اللي هي القوه اللي هي الفورس. المومنتم اللي هي القوه الفورس فبيهمل الفورس انما بياخد في اعتباره الماس كونسرفيشن. اوكي نقطه ايه رفيعه
دايما كده خالص. دايما كده ان انا باخد الفرق ما بينهم مثلا سي هنا الفرق على حسب الموجود دلوقتي ان هو 95%. 95% تبقى الستيبل اللي بيشتغل على السوفت وير. لو اي حاجه اقل من كده مش بيحس بيها وبينط على الستيبل بعدين. كل ما صغرنا كل ما السوفت وير كل ما الهبوط اللي بيبتدي يرن بشكل اعلى بيحصل يعني.
او تاني الكلام الايه قبل كل الموديل بيروح يشوف في التايم ستيب اللي فات كل اللي عامله اللي فيه ميه اكتر من 10 سم هو مش ويحل عليه. كل اللي اقل من 5 مللي هو ناشف وما بيحلش عليه. هو ده الخلاصه بتاعت الليل. واخد بالك؟ فهمتوني؟ طيب بعد كده بنتكلم على density. الدنسيتي is assumed to be a function of salinity and temperature. يعني لو عندك salinity temperature الدنيا سهله. طيب. If you select paratropic mode, both temperature and salinity T and S will be constant. اللي احنا الحاله بتاعتنا and the density will not be updated during the simulation. يبقى density constant ما بتتغيرش. When the density is considered to be a function of temperature and or salinity, اللي هيحصل the transport equation for the temperature and salinity must be solved. لو حضرتك قلت له انا الدنسيتي بتتغير في التمبريتشر او في السالينيتي يبقى لازم نحل كمان معادله الايه التمبريتشر والسالينيتي وبالتالي الكمبيوتيشن تايم تو بي تريبل. كل واحد تدخله بيضرب لك المعادله في 2 3 كده تايم كومبيتيشن تايم. فاحنا ما بندخلهمش الا في الايه في الحالات اللي هي فيه باور هو يكون ده فورسنج ترم بقى قوي يعني باور بلانت. The solution of these equations is automatically invoked and the density is updated from the TS. فاهمني؟ معايا؟ طيب احنا مش مدخلينه ها؟ بعد كده بنخش على الايدي فيسكوستي. الايدي فيسكوستي ما يعني سمجوجرافيكي اللي هو بتاع ده هو الايدي فيسكوستي ده ايه؟ وسيله للتغلب على حاجه زي ايه؟ هو دايما بيسموها حاجه اسمها لارج سكيل سيستم وسمول سكيل. لو انت بتعمل بتحل الدومين، والدومين بتاعك فاكرين ازازه الميه عشان ما اقعدش ازازه الميه دي. بصوا كده حصل تربلنس، شايفين اللي حصل في ازازه الميه؟ شايفين الميه والهواء والميكس ده؟ التربلنس ده خلاصته ايه؟ ان في تطورات، ان في طاقه صعبه. اوكي؟ فانا علشان ما احلش الكلام ده بريزوليوشن صغير قوي 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 قوي، فبعمل ايه؟ بستخدم اللارج سكيل بدلتا اكس كبيره وبدلتا تي كبيره، فبالتالي بتغلب على الموضوع ده بحاجه فيرتشوال كده، يعني حاجه اوان ايه اليكس، حاجه تاكل الان تاكل الطاقه. طب مين اللي عمل الحاجات دي؟ في كذا موديل مشهورين. اوكي؟ فبنستخدم الموديل بتاع الاليكس المشهور خالص. فهمتوا؟ هو نوع من انواع التغلب على مشكله التربلنس اللي بتحصل في لحظه تكسر المياه. بيعمل ايه؟
ابروتش مثلا يعني بيحكي التربلنس.
هو مش بيحكي التربلنس، هو كل اللي بيعمله بيضيف ابزوربنج تيربلنس. عاده بيبقى ساكن سيرد اوردر، معادلات من الدرجه الثانيه التفاضليه، ساعتها ماثماتيشن قوي شويه، فبيضيف حاجه ابزورب شويه انرجي. الابزوربر ده الترم ده هو الاي دي فوسفوسفيت، واخد بالك؟ بيضيفوا للمعادلات اساسا، يعني المعادله اصلا ما فيهاش البتاع ده، يقول لك بس في انرجي هتحصل، هو تقول له المعادله ايه؟ ما فيهاش، ما اصلا ما دخلتش المعادله ولا الهواء ولا يعني ما دخلتش المعادله كل الحاجات دي، بس دي موجوده ولا مش موجوده؟ خلاص تعمل ايه؟ قلت لك انا بعد الترم كده من عندي المعادله يمتص الانرجي. ايه؟ وانت وشطارتك كل واحد يعني كل عالم مع نفسه يقول لك انا هدخل الترم ده، واحد تاني يقول لك هدخل الترم ده، والاثنين بيمتصوا. بس مين اللي هنشتغل بيه؟ اللي لما تيجي تعمل له اكسبيرمنتال وتقارنه مع الاكسبيرمنتال يبقى احسن. اوكي؟ فده بنسميه الايدي فيلوسيتي ثيوري. طبعا بقى هو حاطط لك الحاجات الستاندرد، عاده ما بنلعبش فيهم عشان نبقى صراحه مع بعض، يعني الا اذا كنت انت بتعمل دكتوراه في المودلز بتاعت الايدي فيلوسيتي وعندك تجارب من المعمل بعد من سنين شابين وبتعرف تلعب، يعني ده ريسيرش توبيك مش انجينيرنج توبيك. بعد كده البيد ريزيستنس ده مهم قوي، ده نقدر عليه ليه؟ بسيط كده، حاجه في الايه السلكاوي، يعني هو الفريكشن بتاع البيد وضعه ايه؟ فهو بيقول لك هنا ايه؟ selecting one of the two middle options you must specify the cheesy number and the Manning number. طبعا يا اما ما فيش اصلا وده ما بنعملوش، يا اما تاخد بالتشيزي او بالماني، هما الاثنين زي بعض يعني، بس ده يعني لما يزيد المقاومه تقل، ده لما يزيد المقاومه يعني بالعكس. فاهمين؟ فانت تشتغل بالماني، تشتغل بالتشيزي ريسبكتيف. selecting the last option you must last option بقى ده اللي ابراهيم كان بيسال عنه. انت تعرف الترجمه يا ابراهيم؟ انت عليك على فكره، انا عليك منك، انت بتبعت لي رسائل كده، انت ايه انا اللي بتعمل ده؟ على فكره احمد خلي بالك،
دايما دكتور من اشطر المسابقات في العالم.
ده بيسالني اسئله ويحرجني ويعمل ويبعت لي يقول لي مش عارف ايه يا ابراهيم ده ابراهيم ده
بحب السباق ما سالش كتير.
يعني شوف انت قاعد بتعمل كده لكن ابراهيم ده خلي بالك خطير قوي. فالمهم ان في نوع من انواع الفريكشن اللي اتسال هنريك عليه النهارده، اللي هو ايه؟ اللي هو الويف ويف انديوزد بيد ريزيستنس. ده حاجه بتيجي من الويفز، الانتر اكشن ما بين الويفز وما بين البيد، فده ما بيخشش الا اذا دخلنا ويفز معانا كفاصل ده. يعني لو دخلت الويفز يبقى البتاع ده حلو. اوكي؟ معايا؟ ما دخلتش ويفز يبقى مالكش دعوه. فده نوع من انواع الايه؟ فبيقول لك هنا ذا جرين ده بيقول لك selecting the last option you must specify the effective grain diameter. دخلنا بقى الجرين diameter بتاع البيت الديفكت بتاعته ايه؟ with the relative density of the bed material and some wave included induced bed resistance parameter. حاجه كده يعني ايه؟ مكلكعه. اوكي؟ لو انت اخدت التالت ومش هناخده الا اذا دخلنا covered. When Manning number is specified for the resistance type and zone map is specified for the type of domain input, it is possible to specify which formulation should be used. One standard, second flow dependent. عنده بقى هنا فورميليشن اكثر تعقيدا. كان النهارده اتكلم عليها هنريك لو تفتكروا. هنريك كان اتكلم في الموضوع ده بتفصيل اكثر شويه. اوكي؟ اللي هو بقى ايه؟ هقسم الدومين لزونز، والزون دي بقى قعد هو بقى يحط لي شويه ايه؟ مور كنترول اكتر.
حط متشابه اوبشن، انا لو متشابه في كل اوبشن من
يعني ابتدى يعمل نوع من انواع الزومينج والكنترول اكتر في اختيار البيد ريزيستنس. فاحنا ممكن ناخد البيد ريزيستنس 32 خليها 40. طب كل ده حاجات جلوبال. اوكي؟ وممكن اقول المنطقه دي تبقى 30 ودي 20 ودي 25 ودي، وممكن اخش بقى الديتيلز اكتر واقول له ايه؟ لا ده انا عندي هنا بيلدينج. هو انت بقى يعني ظبطها انت. وارتفاع ما هو بقى طالما عندك بيلدينج ففي موديل بيقول له لما يكون البيلدينج ارتفاعه متر يبقى الريزيستنس 32، ولو مترين تبقى الريزيستنس 40، ولو مثلا في موديل بقى ايه البارامترز بتاعت الموديلز؟ بس ده بقى حاجه فيري سبيسيفايد وسوفيستيكيتد قوي. اوكي؟ بيقول لك هنا for the standard formulation a constant Manning number is used and the flow depends formulation. The Manning number is calculated from as a function of either the water depth or flux. لو انت بقى يعني المانج نمبر ده حاجه من اثنين، لو انت هتحطه على البيز على الفلو فبقى يعني ايه هيعتمد على الفلكس. النهارده الحقيقه كان هنا بيتكلم في الموضوع ده شويه، بس انا شخصيا بس يعني ما دخلتش في الليفل ده من الايه من استخدام البيت فريكشن. اخري هحط البيت فريكشن من الحته دي كتير وهنا اتغير منك يعني كده، انما دي انت ماتش مور ايه ديتيل مودلز فور ذا بيت فريكشن. فاهمني؟
دكتور بالنسبه للويب انديوس بيد عشان اشتغل عليها لما كنا بنجربها عشان اشتغلت برضه كاملنج قبل كده، هي مش حاجه انا بقيسها انا بعملها، هي بس ان انا بعمل كاليبريشن بين المودلز باستخدام فريكشن معين وفريكشن ثاني، وشوف تاثيرها على الويب هايت بتاعت ايه وبدخل الكوركشن ده او جبت كوركشن للويب هايت شغل. ان انا بقى بجرب الموديل كذا مره وكذا فريكشن بشوف اثرت قد ايه الويب هايت وادخل الكوركشن دوت تقييمه بس مالهاش رقم مالهاش داتا تخش عليها. بديله نفس ايرور قد ايه. انت اللي قلت لك انت اللي قلت لك.
طيب في المساله بتاعتنا بصوا بقى المانيفيكيشن شكله ايه. The bathymetry data for file is BFS2 which contains the bathymetry bed elevation. لا ده الواد احمد عكس بس مش فاهم وراح قابلني. ده الماني هو شاف حاجه من اولها قال لك ده تبس.
هو دخل مانينج اصلا دخل مانينج
كمان هو عشان يدخله بقى انت بقى ايه شايف البتاع كده تفتحها انت تقدر تفتح الفايل وتتفرج عليه. هو بقى ايه المانينج مش بس بتدخله عن طريق ايه؟ اكنه ديبس. يعني انا ازاي اعمل الملف ده يا شباب؟ بروح للميش جنريتور. مش انا في الميش جنريتور بحط ديبس عند كل نقطه؟ لا هنا بقى مش هحط الديبس، هحط المانينج وهسيف از ديبس ديبس يو بس هو مش ديبس ده مانينج. بس الماتيريال لوجيك تاني. هنا انا رحت هناك على يعني على في الميش جنريتور نفسه وابتديت بقى اقول له بص ده كله شايفين البحر كله احمر اللي هو 33 32 مثلا اللي هو الستاندرد بتاعنا 32 مثلا. لكن لما دخلنا على الارض طب هو عملها ازاي؟ ما هي معقده قوي. يعني قصدي ايه؟
كلاسيفيكيشن ماب
بالظبط. شايفين بقى لما دخلت عملت زوم اعمل زوم على اي حته كده هتلاقي ايه البتاع ده يا عم ده طلع منين ده؟ فهو عنده حاجه اسمها لاندنج جبناها منين؟ من الجماعه بتوع اللي عملوا سيرفي، الدكتور محمد نور مثلا قال لنا والله اللاند يوز اهو. يعني ايه لاند يوز؟ يعني هنا في شجر نخيل، وهنا في برسيم، وهنا في بحيره سمكيه، وهنا في مش عارف ايه. كل واحد من دول بنعتبر له ريزيستنس معين. فلما تقول لي في نخيل يبقى في ريزيستنس قويه، في بحيرات سمكيه ما فيش ريزيستنس ميه. فاهمين؟ فانا هنا على حسب كل منطقه انت تقدر تعمل زوم ان وزوم اوت وتدلع نفسك في تبص ايه اللي ايه، بس ده عباره عن لاند يوز وحطيت له كوفيشنت. لما هو يقول لي لاند يوز سمك حط 32، اللاند يوز نخيل حط. هو طبعا كل حاجه من دول بكود، يعني هو ما بيقولش نخيل، هو بيبقى كاتب كود، بس انا عارف ان الكود ده هو مديني في الجي اي اس. بيبقى عندي الايه الداتا سيت سبيسيفيكيشن، ايوه كلاسيفيكيشن للموضوع. انا باخد الكلاسيفيكيشن ده وانقله احطه على طول بايكويفالنت ماني كوفيشنت. واضح يا شباب الكلام؟ فاهميني ها؟ ماشي. طيب بعد كده بيقول لك الفيجيتيشن زونز. الحقيقه هم هنا مستخدمين الفيجيتيشن زون لان هو اوريدي هو ده برضه هو نفس الموضوع. الفيجيتيشن زون ده هو ما هو الا بتاع ده فريكشن رفنس. هو رفنس، هو لاند يوز، هو نفسه اللاند يوز، بس هم هنا مستخدمينه. اوكي؟ ليه؟ لان هو اوريدي كونسيدرت فين؟ في الماني. ايوه هي عباره عن ريزيستنس، بس ايه هو بني لك مودلز بقى، يعني مدلعها. واخد بالك؟ يعني هو جاي بقى يعني بيدلعها لك. فهو بني لك موديل، انت قول له ايه الفيجيتيشن، انت زرع هنا ايه وزرع هنا ايه وزرع هنا ايه، وبناء عليه هو يقول لك ده الفريكشن بتاعه كده الفريكشن بتاعه. لكن احنا ما استخدمناش هنا. طيب بعد كده الكوريوليس فورسنج، اتكلمت قبل كده في الحقيقه. الكوريوليس اللي هو عجله الجاذبيه الارضيه بتعمل ايه؟ فهو هنا ما عملش كوريوليس. وريني كده فين. لا فعلا هو ده الصح. لما يكون الدومين بتاعك صغير ما انتش محتاج تحط كوريوليس في الاعتبار، انما لو الدومين كبير بتحط كوريوليس لانها هتفرق. هو الكوريوليس عباره عن ايه؟ ان الكره الارضيه بتلف صح؟ فالميه اللي جوه الكره الارضيه، بص انا لما بلف كده الميه عندها نيرشيا انها تحافظ على انها ترجع ورا. يعني الميه هي الميه عايزه تقف، مش هي الميه واقفه، لكن الكره بتلف. فبقى في تندنسي عند الميه اتجاه معين صح؟ التندنسي دي محسوبه من عدد يعني من الكره الارضيه. فانت يعني هتقول لي في كوريوليس او مش كوريوليس؟ لو في انا عارف بناء على ايه؟ على اللونج لات بتاعك. وهي مش لونج لات، هي اللات بس، اللاتيتيود بتاعك. يعني انت بتجيني عند كل نقطه اللاتيتيود بكام؟ حاطط لك كوريوليس الشكل بتاعك. واخد بالك؟ لو انت اصلا شغال في حته قد كده بقى وحطيتها ما حطهاش هي مهمه. طب الاصل يعني انا يعني الاصل مش هي مش هتاثر لو الدومين صغير. يعني اللي احنا عارفينه انها مش هتاثر لو الدومين صغير. اوكي؟ دي the effect of Coriolis force can be included in three different ways. يا اما no Coriolis force، يا constant in domain، يا varying in domain. If the constant in domain option is selected, the Coriolis force will be calculated using a constant specified reference latitude in degrees. هيحسبها كلها الدومين كله حاجه واحده. If the varying in domain option is selected, the Coriolis force will be calculated based on the geometrical information given in the mesh file. انا متهيألي في دلفت هو بياخدها كونستنت، مش فاكر حاجه. بس مثلا في ار ام اي، برنامج اسمه ار ام اي ده بيقول كان بياخدها كونستنت. هو يقول لي دي افرج بتاعت مين كده الدومين بتاعك، فانا اقول والله الافرج بتاعتك كذا. في دلفت مش فاكر. اوكي؟ انما هنا بيديك الاوبشنز، اما الدومين كله يتاخد فاليو واحده، وده عاده لو الدومين صغير، او كل نقطه في الدومين لو الدومين يحسبها هو. اوكي؟ بعد كده الويند فورسنج تيرم، فهو قال له دخل الويند عندي ومديله الويند فايل. فهنا بيقول لك ايه it is possible to take into account the effect of the wind on the flow field. هدخل الويند. The format of the wind data can be specified as يا اما constant, the wind is blowing from the same direction and with the same magnitude for the whole simulation period and over the entire model domain. فاكرين المسألة اللي احنا حلناها؟ فاكرين كانت constant ودايركشن وكل حاجة constant ما تتغيرش. يا اما عندك varying in time and constant in domain. يا اما هي constant على varying in time constant على الدومين. يعني انت بتتكلم على اسكندريه، منطقه اسكندريه مين يمينها اللي شمالها، ما تقوليش الويند هنا كذا والويند هنا، هي كلها ويند واحد بس النهارده غير بكره. اوكي؟ فانت بتحط ايه التايم هيستوري بتاع الويند. يا اما الحل اللي هيكسر بقى varying in time and domain وذا magnitude and direction varies during the simulation period and over the model area. يعني بقى حاجه معقده قوي. عندك ستيشنز كتير بقى. اوكي؟ فانت عندك ستيشنز كتير، كل ستيشن بتديك قراءات. اوكي؟ فهو هنا خد ايه؟ varying in time constant in domain. يعني approximation. ممكن تقول لي مثلا يا مصريه بورسعيد ما كانتش فيها نفس النواه بتاعت اسكندريه مثلا في الويند، لكن ايه يعني اكسبتبل. اوكي؟
السلكت اللي هو الفايل بتاع الويند بقى، الفايل ده بيبقى عباره عن
هو هيديك الفورمات بتاعته. لو دي اف اس يو هتجيبه من ها؟ زيرو دي اف اس زيرو من كاريت، واحنا فاكرين لما كنا من كاريت اللي هو تكست اللي عملنا له كوبي وخدناه احنا كرتناه مع بعض في الليت باك كذا مره سيلوز. بص هو انا مش عارف هنا حاطه ولا انا مش حاطه اهو. ده الويند فورس. بص كل اللي هنعمله هنا مش مختار ولا ايه؟
موجود عندنا بس ما
موجود عندك انت؟ اوكي
لو عملنا فيو هيظهر.
اوكي فهو في
نشوف عندنا
شوفوا عندك فيو كده في الداتا، وهنا تايم سيريز، ده الووتر ليفل سيناريوز، ده الووتر ليفل صح؟ هو كان موجود في انهي
وين
ها؟ في ويند هنا؟
ممكن هنا تلاقي ده سيزين ايوه سيزين.
لا اصل ده الووتر ليفل. ايوه الويند 10 يعني شايف الويند 10 دي؟ واخد بالك منها؟
ايوه
هنا سيلكت ايتم وهنا الشيت ده بلا 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 كده. اوكي فده الكوبي شايفه ده كنترول كوبي، تروح توديه اكسل. انت فاهماني؟ تجيبيه من اكسل وتوديه اكسل. اوكي فاهمين يعني؟ نرجع ايه للبرزنتيشن تاني ولا نقف وناخد البريك؟ نقف ناخد البريك علشان احمد قاعد باصص لي وانا الحقيقه برضه مش باصص له، احنا الاثنين باصين لبعض. فاحنا ريزيوم احنا واقفين على ايه؟ على الويند فورس. اوكي يا شباب؟ بريك لمده ساعه. اوكي يبقى هنلتقي الساعه 2 و10. ارجوكم 2 و10 ها؟ تدفع كام؟
الفايده
خلاص معلش حاجه.
ايه يا دكتور ابراهيم؟ سامع دكتور ابراهيم؟ سامع دكتور ابراهيم؟ الطريقه اللي انت بتقولي عليها طريقه كويسه قوي. المنتهي ده طلعت الدكتور. احنا المفروض لما ناخد بريك نعمل كده. Yes.
Okay, so good. Hello, everybody. This presentation is about the explanation of a statistical analysis of the hydrodynamic model results. So we are starting this presentation with the baseline of you knowing how to use Mike 21 flexible mesh. So this is the hydrodynamic module. So with this assumption in our mind, these are the contents of this presentation. So the first part we'll talk about will be very quickly, we'll go through the input and output of the hydrodynamic module from Mike. Then in the second section, we will talk about the water level and the different components in the total water level, which are the tidal component and the storm surge or residual component. The third section will present to you the different tools available for you to do a tiding analysis, which the tiding analysis is basically for you to get from a time series signal of total water levels that you will be able to split it in the tidal component and the storm surge or residual component. After that section, the following one will describe a bit on how to treat or how to handle water level time series for you to perform an extreme value analysis. And last but not least, the last section will cover a couple of useful concepts for coastal engineering that may be of your interest, which are topics like sea level rise and the trending of your time series of water levels. Prior to me starting with section 1, and because we have a limited amount of time, I am starting this presentation under the assumption that the audience knows the very basics about the tide. I mean, I am assuming that the audience knows what the different water levels are, so what the highest astronomical tide is, what the lowest astronomical tide is, what the mean sea level is. I also assume that the audience knows what the spring and the neap tides are. And I am also assuming that the audience knows how the tidal currents distribute over the time along an ellipse. So this is the tidal currents. Every 6 or 12 hours, they rotate. So they go from one direction to completely the opposite, and so on, and so on, and so on. And this is by following an ellipse, what we call the tidal ellipse. So these are the basic, very basic concepts about the tide that I am not going to spend time in this presentation because we have a limited amount of time. So having said this, let's go with the first section, which is the input and output from Mike. So what you see on the screen are, I have taken a couple of snapshots of the relevant sections in your Mic 21 FM dashboard. One of the sections is the one regarding the wind forcing that you are going to impose in your model. And the other one is highlighting the boundary conditions that you're going to apply in your model. The wind part of the input, which you can see to the right of the screen, is related or is going to have an effect on the meteorological component of your total water level that is going to be the output from your model, which is going to be the output from Mic. As you can see in that section, when you are imposing a wind forcing in the model, you can see that there are three variables that are considered, which are, they can be either the U and V components of the wind, or instead of them, it can be the wind direction and the wind speed. And the third variable, meteorological variable that is considered is the air pressure. So the wind and the ambient pressure are going to have an effect on the total water level in the meteorological part. Now we swap to the boundary conditions. Now we swap to the right. And in the boundary conditions, here is where you specify along the boundaries of your model how the tidal signal, the tidal elevation, is going to progress from the boundary towards the inner side of your model. So in this section, the boundary conditions, what you are going to apply in here is going to have a direct effect in the output of Mic regarding the tidal part of the total water level. We say this in a different way. If you have a hydrodynamic model and you don't apply any wind forcing, so this is no wind field or no ambient pressure, and you only force your model with tidal conditions along the boundary, the output of the Mic, of your Mic hydrodynamic model, will only feature the transformation of the tide. So your total water level that you get as output from Mic will be only related to the tide. Likewise, if we, in your model, if you don't impose any boundary conditions, that means that you're not imposing any tidal signal at the boundary, but you're imposing only meteorological conditions to the model. Those are the ones that are going to drive the water mass from the boundaries towards the coast. And those are wind and those are pressure. So then in that scenario, the output from your model, from your Mic hydrodynamic model, the water level associated to the output will only tell you things about the meteorological part of the tide. You are not simulating, of the water level. You are not simulating tide, so Mic is not going to compute the tide for you. It will only give you information or output based on the meteorological part of the forcing. Good. Having said this, in this slide, you have a typical output for a DFS0 file in the Mic hydrodynamic module. This is the output at a specific point within your domain. And usually you output or your request from Mic the following outputs. You can ask for the surface elevation. You can ask for still water depth. You can ask for the total water depth. You can ask for the U and V components of the depth average total current that is modeled, or you can also ask for it in the form of a module or a speed and direction. For the purpose of this lecture, we are going to focus on the output, which is surface elevation, And although we are not going to focus a lot in the analysis of currents, which the process is exactly or basically the same as for water levels, I'm just highlighting, for you the main outputs that you're interested in, which are the current speed and the current direction. Here I'm making some observations for you to not forget when you are handling the output data from Mike. And is, for example, if the if you're imposing boundary conditions of tide in your model, and those boundary conditions are referred to the mean sea level, then the output of Mike that gives you the surface elevation, it will also be referred to the mean sea level. Meaning that if something is referred to if the sea surface elevation is referred to the mean sea level, that means that taking the mean sea level as the center of your reference system, taking it as 0, you will have values of the sea surface elevation going up and down, above and below the 0 level or the mean sea level. If, for example, your signal is referred to the LAT or the chart datum, in that case, your surface elevation will always be positive because it's referred to the bottom level. But in this case, the standard way of doing things in Mike is considering the mean sea level. So if your input is regarding mean sea level, your output will be referred to mean sea level too. More things to bear in mind. The current speed is output as it should be in meters per second. But when you output current directions in Mike as a DFS0 file, you need to be aware that the direction is given to you in radians, not in degrees. The oceanographic convention for directions of the current is always directions are given as going towards from north. So Mike gives you that information, but the only problem is that the units are radians, not degrees. So whenever you want to do something with this information, especially if you are going to do a detailing analysis, make sure that you convert those radians to degrees first. And last but not least, since we are dealing with Mike 21 FM, you need to be aware that the current values that you get as output from Mike are always depth average values. It's just a single value that represents the entire local water column. Good. So now that we have gone through the input and output of Mike 21 FM, now we are going to describe what is a total water level. So in this plot, you can see a time series of sea surface elevation at a certain point within your model. In the x-axis, we've got the time, and in the y-axis, we've got the level. As you can see, the level in this plot, because I took it from a book, not from the direct from Mike, you can see that the level is not centered in 0. So we have the measured water level, which is the blue, but then it is not centered. It doesn't go up and down around the 0, but the 0 is in here. That means that the level is referred not to mean sea level in this plot, but to something like chart datum or LAT. Apart from that, the concepts and the information that this plot has for you is exactly the same. So you shouldn't get confused by this. Okay, I'm going back to the explanation. So let's say that we've got a time series in blue, which is, let's say, the output of my model. So this is the total water level that I get as output from Mike at a certain point. And also bear in mind or consider that in this simulation, I have imposed both tidal forcing along the boundary of the model, but also atmospheric forcing all over the model domain. So this is, I'm imposing wind speeds and directions and also air pressure. Good. So the total water level at any given time is always the combination of the tidal elevation that is happening at that moment plus the contribution of the meteorological part to the total level. So total water level is always the part of the tidal component plus the storm surge component at the same time. Going back to this picture, we can see that in blue we've got the total level, and then if we were able to decompose the tidal and the residual part or the storm surge part of that signal, we will have something like this. We will have the astronomical or the tidal signal, which is the red series, and then the difference between the astronomical part of the total water level and the total water level, so from here to here, is what we call the storm surge, or is what we call also the residual part of the tide. It's as simple as that. It's a summation of the two components, so this is not rocket science. In that plot, you can also see the definition of skew surge. I'm not going to go into it because it was just disclosed in the figure, but here you have the explanation of what the skew surge is. It is not needed right now for the purpose of this presentation, but in there you have the definition of the skew surge. But basically here I wanted to show you that any water level can be decomposed in its astronomical component and the storm surge component. Good. So now very quickly, now we see that the total water level has two components, the tidal part and the storm surge part. So now let's go through some of the characteristics of the tidal part. So the first thing is that the tidal part of the total water level, let's say the tidal level, tides are only or mainly or 99.9% defined by the relative motions of the Earth and the Moon and the Sun and other planets in the solar system. I say in there deep water because basically this behavior of purely of the tide or of the water mass just influenced by the Moon and the Sun only, it happens in deep water. Now, when the tide that is, or the water mass that is in the middle of the ocean comes close to the continental shelf, let's say it arrives to the continents, to the different countries, then the tidal signal is modulated or affected by things like the latitude. So the tides do not feel the same pulling from the sun and the moon in high latitudes than at the equator, for example. All the things that affect the progression of the tide are the local water depth, where your tidal signal is progressing, and also the continental boundaries. The shape of the land has an effect on how the tide accommodates and travels from offshore to near shore, and how the water mass has to fit with the shape of the continents. And this is something, an effect that you can see when you go into intermediate or shallow water. It's not that you cannot appreciate it that much in very deep water, but as soon as you get close to the coast, you see the effect. Good. More things that we have to know about the tide is that we have said that the tides are basically produced by the relative motions of the Earth and the different planets in the solar system. So, if we know how those planets move relative to each other, then what we can do is we can tell exactly the state of the tide at any time, and not only in the future. I can tell you right now what the tide is going to be in 30 years' time in, I don't know, in the port of Barcelona in Spain. But also I can tell you in the same way, because I know how the planets have been moving since many million years ago, I can also tell you how the tides were at any given time in the past. And why? Because we know exactly the paths of the planets and the velocities of the planets. And with that information, you can define exactly how the tide is going to be distributed in the world. What I'm saying in the following point is basically that you know the relative motions of the planets. So then you know the motion equations of the planets. Once you know the motion equations of the planets, from there you can calculate what we call the tidal constituents, which are basically sinus or cosinus functions with an amplitude and a phase. And with those tidal constituents, then you can describe completely how the tide was and the tide is going to be at a certain location of the world at any time that you want. Again, I'm stressing it at the very bottom. Once you know the constituents of the tide at a certain location of interest for you, you can tell absolutely or with a high degree of accuracy how the tide was at any time in the past and also at any time in the future. That's what we call a deterministic approach. You know exactly the value that that variable of that tidal elevation is going to have at any time of either in the past or in the future. Good. Other thing that we need to know about the tide is that since the tidal levels and currents are determined by the relative cyclical motions of the celestial objects, then that means that the maximum and the minimum values that the tide, the tidal elevation can reach are well defined. They cannot grow infinitely or they cannot decrease infinitely. They are well defined within a range of values. And the same goes for the associated tidal currents. In the plot to the left, there are many signals in here, but I would like you to focus on the second one. The second one is an example of tidal elevations at a certain location. I don't know where it is, if it's in Australia or whatever, where you can see that the tide goes up and down, up and down, up and down in what we call a spring cycle. Then in here it goes into what we call the nip cycle, and then it grows again. But as you can see, there is a moment when the tides cannot go below a certain value or above a certain value. And that is because it is the tide is completely controlled by the planets, and the planets always move in the same fashion, so you cannot get values outside of those ranges. The same thing goes if we pay attention to the 1, 2, 3, 4 to the fifth plot or time series, where we've got the evolution of the tidal current, which follows the same fashion as the sea surface elevation. The values of the tidal current, or just the tidal component, can only range between a certain minimum value and a certain maximum value. You cannot have values above or below those ones because they are completely defined by the progress of the planet.
Excuse me, Robin.
Yes.
I suggest that you use the laser pen to follow you on the screen.
Pardon?
First, use the laser pen.
Where is yes, this one, and then laser pointer. Okay.
This is number one. Number two. Two. Try to zoom in figures. When you talk about some figure, it's preferable to zoom in. Thank you.
Okay. Good. So, for example, going back to what I was saying, the second plot is giving you a typical tidal. What did it here? It disappears if I make a zoom. Then the laser pointer does not follow. So I have to use the laser with the original size of the plot. Anyways, you're going to have this presentation afterwards, so you can pass your notes or translate your notes to the presentation whenever you want. But what I said is that basically the second plot and the fifth plot tell you about how the tidal elevation and the tidal currents behave within certain well-defined limits. And that's a direct consequence of what causes the tide, which is the relative motion of the planets. The motions of the planets are always the same, so your values of tide should be within a given maximum and a given minimum. Good. Now that we have said this, so we have got a glimpse on how the tides work, what the tides give to us, and the kind of values that we should expect from the tide. Now we go into the search component of the total water level. So as I said before, the tide is a deterministic environmental variable because it's completely defined by the motions of the planets that we know how they work. But the search, in opposite, is something that is related to the local weather that is happening at your location of interest. And as you may know, as you should know, the weather is not deterministic. I mean, you can expect bad weather during winter where you live, and you can expect good weather during the summer. But still, that's the only thing that you can say, because you cannot say exactly, for example, if you're in October, how the wind and how the air pressure is going to be in 2 months' time. You don't know. You can expect that it's going to be harsh, but you cannot tell exactly which day and at which hour the peak of the storm is going to happen. So things that we can see from this slide again is in this figure that I'm showing in here, we can see that the total water level is a combination of the tidal part of the water level, and then on top of that, we have the meteorological component. So we have wind blowing over the sea surface, and that wind blowing over the sea surface causes the water mass to be pushed in the direction of the wind. And that causes that the water mass builds up over the surface of the sea. So it's generating an artificial elevation of the water mass, and just because of the wind that is blowing and is pushing the water at the sea surface. But not only the wind is causing variations in the water level. If you remember our first slide where I was showing you the different inputs that you can pass to Mike, we had for the wind, we could pass information about the wind in either U and V components or wind speed and wind direction, but you can also, or you must pass information about the air pressure. How does the air pressure affect the sea surface elevation? It can be seen in this plotting here. So for example, when you have a high pressure system going around the sea surface at a certain location in the world, when you have a high pressure system, that means that winds are going from the up from the atmosphere down to the ground, bringing good weather because there are no clouds, but it is also pushing all the atmospheric layers from up to down. So that causes that the water level or the sea surface is pushed by that high pressure. So in the end, when you have a high pressure system over the sea, the local water level goes down because it is pushed by that high pressure. Likewise, when you have a low pressure system is basically a revolving storm. You have the opposite effect. You have winds that are around that are flowing along the sea surface, and they go up into the atmosphere. So what happens? That creates kind of a vacuum effect. So basically, the atmosphere is sucking what it's in the over the sea surface, and it's pulling it up towards the stratosphere. So the passage of a low pressure system pushes the mass of water up, increasing the water level. And remember, this is just due to the meteorological conditions of the site. This has nothing to do with the tide. We said before that the tide is completely independent from the surge. And when you combine the two of them, is when you get the total water level. Good. More things that we have to say in here. Regarding meteorological surge, you may be able to hindcast the storm surges up to 70 years back in time. I mean, you go into ECMWF databases or any research atmospheric models, and you may be able to find information since, I don't know, since 1950 or 1930 up to today. But what you will not have is a forecast beyond 5 days. Why? Because you don't know what is going to happen in the future. You may have an idea, but it still is not as deterministic as the tide. Remember, with the tide, you can tell exactly how the tide is going to be in 30 years' time, because you know exactly how the planets are going to be aligned in 30 years' time. But you cannot say how the surge is going to be at a certain location in 15 days. You may have an idea, but you cannot tell exactly how the surge or how the pressure systems are going to be in 15 days, exact hour by hour. That's why we call it an indeterminism. You cannot say exactly the value that is going to have in the future. Last but not least, but this is something that it's very curious, I have to say that whenever you have your peak tide, so this is the tidal component of your total water level, whenever you get to the highest water level in the day, the surge, or the contribution of the meteorology to the total water level, does not happen exactly at the same time. There is something that we call a delay that ranges between 15 minutes and up to 2 hours. So the peaks are happening at different times. It does not mean that the peak surge occurs at the same time as the peak tidal elevation. This is a concept that you should carry in your mind always. Good. So so far we have talked about the different components of the tide, of the total water level, how the tidal component originates and what you can get from it, and how the meteorological conditions affect the local water level and what you can expect as an output from the model. Nice. Now we are going to talk about the tide. So let's say that you have set up your Mike model and you have forced it with both tidal boundary conditions along the boundaries and also meteorological conditions or atmospheric conditions. So this is wind and air pressure. As a result of that, the outcome of your simulation will be a time series like this at a certain location, and you will have variables like surface elevation and current speed and current direction. The surface elevation will have been generated taking into account at the same time the tidal part and the meteorological part. So you have the total water level. But then the thing is that it may be in your interest to decompose your results in the purely tidal part and the purely meteorological part. Why? I will go into that in 2 slides after this one. Just bear the concept. You have an output from Mike where you have been forcing it with tides and with atmospheric forcing. And now you want to split your output in the tidal part and the meteorological part. How do we do that? Well, to summarize, basically the tidal analysis allows you to decompose the total water levels. Yes, and also the tidal currents. Sorry, the total currents. Then, for an accurate description of the relevant tidal constituents, long-term time series are needed. So this is, let's say that you have a simulation of 6 months in your hydrodynamic model. You have been forcing that model with tidal conditions and atmospheric conditions, and you have 6 months of data, a time series. And then you want to analyze the tidal component and the surge component of those 6 months that you got as an output from Mike. You can perform this detiding analysis for sure, but the problem is that your time series is so short that the motions, the relative motions of all the planets are not going to be well described. Why? Because you have only 6 months of data. That is very little time to be able for you to describe the complete motions of all the planets within the solar system. At least it is recommended for you to have a full year of total water levels. And what is better, if you have at least 18.61 years, then much better, because if you have at least 18.61 years of data, when you perform your detiding analysis, you can be sure that the tidal constituents that you get from the analysis are as accurate as they can be. And with that information, then you will be able to hindcast and forecast tidal elevations in an accurate way. Why do we say that we need 18.61 years of data in order for us to get a good description of the tide? This is related to something that we meteorologists call the lunar nodal cycle. And what is that? You have this, you can see this fancy animation here in this slide. And basically it's showing you the following thing. And it's, think of the Earth. We've got the Earth and it's rotating. And we know that the Earth is slightly tilted. So it's not, the north and the south are not completely vertical, but it's just slightly tilted. And then around the Earth, we've got the moon rotating. But what's the problem with the moon? And it's that the moon does not keep the same orbit around the Earth. So it goes up and down the equator somewhat 5 degrees. And it takes for the moon 18.61 years to complete that cycle of going up and down 5 degrees above and below the equator. So that's the thing, that the moon is changing all the time, and so its effect on the tides. So if you want to capture all the interaction of the planets, and especially the moon, because the moon is the main driver of the tide on Earth, if you want to precisely describe all the components that create the tide at a certain point, you need to have 18.61 years of data. Why? Because you ensure that you are capturing the entire cycle of the moon rotating around the Earth, going up and down 5 degrees around the equator. If you have less data, you will be able to perform the tidal analysis and get the tidal components, yes, but they will not be as accurate as if you have at least 18.61 years. If you have 20 years or 25 or 40, even better, but at least 18.61 years. Good. Having said this, how do we do this? So I can tell you that out there in the market or in the internet, there are tidal analysis tools that can assist you to perform basic tidal analysis from time series of both model values or observations. So it doesn't matter whether you have a model time series of total water levels or you have a time series measured by a tidal gauge. because the procedure is the same, because the physical variables are exactly the same. So it doesn't matter if it's measurements or model data. You can always decompose both of them in the tidal component and residual component. Good. So with tidal analysis tools, you can, for example, compute the relevant constituents of the tide that will allow you to hindcast and forecast tidal elevations and the tidal currents. One thing that you have to bear in mind is that the constituents that you derive from a sea surface elevation signal are not the same as those that you can derive from a time series of currents. I mean, both of them are associated to the same location on Earth, and they will give you the corresponding sea surface elevation or currents. But the values of the components are not the same. So for example, if you compute the components of the sea surface elevation, you cannot use those values to compute the associated tidal currents, because you will get wrong values. And the opposite, if you were starting with current values, and you do the tidal analysis, and you get your current constituents, from those constituents, you cannot compute the tidal elevations, because those values are completely wrong. In the sense that they have different units. So if you want to tell something about future or past sea surface elevation, you need to perform the tidal analysis on sea surface elevations. You want to say something about the future or the hindcast currents, you need to perform the analysis on the currents, and then you will get the different components. Apart from that, don't worry, because the software that I'm going to recommend you to perform this analysis tells you to do so, and tells you to perform some checks before you put your hands into work. If you have a time series of sea surface elevations, from there you can get your tidal constituents of the sea surface elevation, and from those constituents you can compute values like highest astronomical tide, lowest astronomical tide, mean high water springs, mean high water neps. I'm sure that you are familiar with all of these concepts. And here, for example, I'm presenting you with an excerpt from this paper, where it tells you how to compute the different water levels, like mean high water springs, mean sea level, mean high water neps, based on the values of the constituents that you have computed by means of the detiding analysis. So this is one of the reasons why you should be familiar with the detiding process of your tidal signal, because by performing that analysis, you will be able to tell about all of these levels. And any of you that have worked in any coastal projects, you are aware of how important it is to define the different water levels at the location of interest. Because you may have a vessel that needs a certain underkeel clearance for it to reach the harbor, and then you don't want the water to drop below a certain level, or you want to design, I don't know, the pier or the quay where the vessel is going to unload its load, and you want to have that quay at a level that is not hit by incoming waves, for example, and then you need a certain height. So that's the reason why you need to define the water levels at the location of interest. And what's the best way of doing this? By performing a detiding analysis of your total water levels, which result from your MICE simulations. I hope that this is not a tongue twister and you got the concept, and I'm pretty sure that you did. So now we can move into the following slide. And in here, I'm just presenting you and giving you a hint of where you can get this detiding tool. So basically, there are lots of, there are several tidal analysis tools out there in the internet, both free and commercial. I would say that apart from some nice interfaces or graphic outputs from the commercial models, The freely available models, which are basically developed by universities, they give you exactly the same information. So you just need to you will not have a nice interface for you to select your data, blah blah blah, but the output will be the same. And based on my experience, this software that I'm introducing you to has never given me a bad moment. So as a matter of fact, this is kind of an industry standard. Whenever you say in your report that you are making use of this tool to perform the detailed analysis, that it's enough guarantee. So basically what I want to show you is that I would recommend you to use this UTIDE package. This UTIDE package has been developed by, back then, 10 years ago, then a student called Dan Codiga. And he offers, or he released his software for free. You can find it both in MATLAB and Python versions. And the links are in here. So whichever you produce, you are interested in, or is your preference, you can find it here in here. These software packages come with compressive documentation, both scientific documentation on how the tides work and how they are computed and the different constituents are computed, but also it comes with a user manual that is very easy to follow and for you to understand what you are doing at any time, what you are passing as input and what you get as output. So that's what I have to say about the tidying tools. I just wanted to show you in here. Let's see, I need to, I will make a zoom into this plot. I will lose the pointer, but then you can see. For example, with the detidying analysis or the tidying tool, you are starting with the time series of, it can be sea surface elevation or it can be currents, doesn't matter. But let's say that we start in this example with sea surface elevation. So let's say that in here you have a time series output from your Mike model at a certain location. And then you see that you have this kind of pattern that goes up and down. It's more or less, it has well-defined maximum and minimum values, but they are uneven, right? So sometimes you'll get close to the minimum value. Some other times you get way far from the minimum value. But in the overall, you see that the water levels are going up and down around the mean sea level. So if you pass this time series to the UTIDE or the detidying software, what it will do for you is it will decompose that total signal that has tidal component and surge component into its two components. So you will get, in the end, the tidal component, and now you can see that it's a regular thing. It's cleaner than the signal above. Why? Because why is it cleaner? Because I told you that the tide is completely defined by the motion of the planets. And the motion of the planets is basically a dance. It's basically a ballet. So it's smooth. It always repeats. So that's the reason why you get, as an output from the signal, something smooth and clear. Whereas what is the difference between this, the total water level, and your tidal component, what is left is the residual component. And the residual component, as I told you before, it is not deterministic. It is not it's not a cycle. It can be noise. You can interpret it as a noise signal. So you can see here that it gets a peak in here, and then it gets kind of steady throughout the year, and then all of a sudden, then you get another peak in here. But it's not as regular as the tide. And this is the reason why I'm telling you that while you can say things about the tide in the future and the past, you cannot say a lot about the surge in the future. Because beyond 3 or 5 days, or maybe 10 days in the future, the models are not capable of telling you exactly how the surge component is going to be. But this is what you get from the detidying analysis. Good. So now we can go into the following slide. In here, I'm talking about extreme value analysis. I am not going to go into the detail of performing an extreme analysis on any time series in here. Why? Because you have seen that in previous lectures in this course. I gave you an introduction and even an example on how to perform extreme value analysis based on a Gumbel distribution for annual peaks of wave heights. The same procedure can be applied to water levels. So that's the reason why we are not spending time on the analysis itself. My colleague Andrea also gave you a lecture on how to use the different analysis tool to perform extremes analysis. So the only difference that we have in here with regards to the examples that you have seen in previous lessons is that before you were using a time series of, let's say, wave heights, and now your input will be a time series of water levels. The rest is exactly the same. So having said this, let's go very quickly on the details of the extreme value analysis for water levels. First, and most important, there is no difference in the way of performing an extreme value analysis on either total water levels or surge levels. You follow exactly the same procedure. There is nothing different in the data. Second, it does not make sense at all to perform an extreme value analysis on the tidal component. So if you have your total water level and you decompose it in tidal and residual, it will make sense for you to perform an extreme value analysis on the total part, on the total or in the residual, but not on the tidal part. And in here, I just want to ask the audience, may anybody tell me why is this? Why there is no, it doesn't make sense to perform a tidal analysis, an extremes analysis on tidal water levels or tidal currents?
Muhammad mentioned that because it is always within the range, the normal range.
That's it. That's correct. It's because you know exactly the tide in 20 years or 40 years, it will go above between certain range of values. So you know exactly how it is going to be.
Excuse me,
So
you gave me.
Yes.
The upper one. Thank you. Please go ahead.
Good. So that's exactly, you know exactly that it goes up and down between certain levels. So there is no point in making an extremes analysis because after 1 year, all the values will be exactly the same, both for the maximum and the minimum. So there is no point. But if you're considering the total water level, yes, in the end, you're considering the tidal component, but also the residual component. And the residual component is the one that is going to make the difference in different return periods in your analysis. Good. Another thing that I have to say is that I've been scaring you about with this the tithing process, right? You were living happy and self-confident, knowing that you have as an output the total water level and that you can perform an analysis, an extremes analysis on total water levels. Is that okay?
Yes, everything is okay.
Okay, sorry. So I was going to say that you were living happy before knowing that there was something called the tithing. You were thinking that, okay, I have my time series of total water levels, and then I perform my analysis on those time series, and then that's it, and I am done. And then this guy Ruben is telling us about decomposing it in tidal part and residual part, and talking about the tithing software. Why is he making things so complicated? I have to tell you that, strictly speaking, you don't have to carry out the tithing step. you can perform your analysis on the total water level. No problem with that. But as I say in the next bullet point, the engineer carrying the analysis or carrying the task of providing extreme water levels and tidal elevations, you have to be aware of the assumption that you are doing when reporting the results of the analysis. I mean, you can have your time series of total water levels and say, I don't want to spend time doing the detiding, or I don't understand the detiding completely, and I fear that I'm going to commit a mistake, so I will perform my analysis on the total water level. Good, that's fine. Nobody's going to take you to jail for doing that. But you have to be honest, and when reporting the results, you have to say that you have considered the total water levels, that you have not split it in the tidal and the residual component. Why is this? So let's go into the following bullet point. Delivering total water level return values implies that the engineer accepts that future total high or low water level events will follow the same time occurrence on the tidal and residual components. What do I say with this? Let's have this example. Let's think that you've got 20 years of data of total water levels. Okay, you have your model, you have run your Mike model, and you have 20 years of data of output. Sea surface elevation, 20 years. And also let's say that a higher, or whoever controls the weather in this universe or in this life, however you want to call it, has made that during those 20 years, you have your tide going up and down, up and down, up and down, and you also have your storms happening. And let's assume that the person or the entity that controls the weather decided in its power that during those 20 years, the maximum storm surge was occurring at the same time of the highest or of the high water level. So let's say you had a massive storm with an associated surge level of 1 meter that was happening exactly at the same time when you were having a high tide. So let's say plus 2 meters above the mean sea level. And this is something that has happened for every single storm during those 20 years. Good. So that means that when you perform if you don't split that signal into the tidal and the residual component, what you are saying from your analysis is that for future events, let's say with 50 years of return period, 100 years of return period, 200 years of return period, you are assuming that the tide, the high tide, and the peak surge will happen at the same time. Why? Because that's the assumption that you have made with the 20 years of data that you had. So the results from your analysis will carry on that assumption with them. And now the question is, can you put your hand in the fire and say that whichever storm happens from now on in the future, the storm surge, I mean, the peak of the worst storm that you can imagine is going to happen exactly at the same time when you reach high water level of the tide? Because it can be that storm arrives 2 hours before or 3 hours later than when the peak of the tide happened. So those two peaks will not be coinciding. So it may be that you have the largest storm surge ever, but at that moment of the life, it happened when you had the lowest water level of the tide. And when you combine the lowest water level of the tide with the highest peak of the storm surge, it may be that combination is not as bad as when you have the high tidal level, the highest tidal level occurring with a slightly lower or milder storm surge, which will give you a total water level way higher than the previous one that I was telling you to. I want to ask the audience, is this concept clear, or do I need to repeat it in a different way? Because this is very important, because this is telling you why you should perform the analysis of water levels, splitting it in the tidal and the residual component. Is this clear?
امين النقطه دي يا شباب فيها ولا مش قوي؟
Okay. Good. So then the most accurate way to provide the extreme water levels in an extreme value analysis would be for you. You have your total water level time series, and then you split it in the tidal component and the residual component. For the tidal component, you don't have to create, we have agreed that it is stupid to perform an extreme value analysis on those values because you're not going to get any difference in any return period. But you will have the tidal levels. You put them, you cast them aside, you keep them on the side. And now you have your residual time series. And you perform your analysis on the time series of residuals or your time series of search. And then what happens? That once you've got your residual return levels, you can say, look, or you can report in your technical report, look, this is how the distribution or the different return periods associated to the storm surge is. But I'm telling you that this surge can happen at any time of the state of the tide. It can be that these residuals happen at either high water level or at mean sea level or somewhere in between, or even at the lowest water level. Tide, I'm talking about the tide in here. So when you put them together, the two of them, it may be that you don't get the worst case scenario. So that's why you have to you leave that information in the report. You have the water levels, and then you have the tidal water levels, and then you have the residual return values. And then it's up for the engineer that is making use of that data to say, okay, I'm going to consider the worst surge that I can get in 200 years, and I'm going to assume that it happens at the time when I get the highest astronomical tide. When you combine those two values, you are sure that you are getting the worst of the worst combination possible. You're saying that it's going to happen, the storm surge, when the tide is highest, and then you get a massive water wall. But you can also say, okay, I'm going to combine now. What would happen if that 200-year return period surge happens at the time when I have the lowest tidal elevation? When you put together those two values, it may be that it's not as bad as you were thinking in the beginning. Good. So if we have this concept fresh in the head, then the only thing that is left for me to say about this is that it is always recommended for you to carry out the analysis of water levels, either total water levels or residual water levels. You split it in two analyses. One is for all the positive values, and the other one is for all the negative values. So basically, you have your sea surface total sea surface elevation output from Mike. You take those time series, and then it's as simple as that. You take and create two series from that. One for all the values that are above 0, and the other one for all the values below 0. And then you carry out the extreme value analysis on those series as usual. Okay.
Just one more. I would like to talk to the audience in Arabic.
Absolutely.
Okay.
Absolutely.
هو الموضوع ايه؟ الموضوع ان ايه اللي بيحرك سطح الميه؟ اللي بيحرك الميه كتير اساسيين. حركه التايدز ودي حركه بالانجليزي ديترمينستيك. يعني ايه؟ يعني معروفه تعريف تام لانها جايه من حركه القمر والشمس. فنقدر احنا عارفين القمر والشمس رايحين فين امتى فاكيد حاجه كده. اذا حركه سطح الميه نتيجه حركه التايدز والديفايند معروفه تماما.
بص الاولاني اعرف ان هو ده جراديت للتايب. بص الاولاني
ان ازاي تعرف التايمز في اي لحظه، فدي معروفه تماما. لكن في عنصر تاني راندم عشوائي، ايه هو بقى؟ السيرف، اللي احنا بنسميه جاي من الويند او جاي من البريشر. فالويند والبريشر فيه راندم ريتس عاليه، فما نعرفش دول هيبقوا ايه. حركه سطح البحر اللي احنا بنحسبها بمايك بتبقى الاثنين على بعض، فاحنا بيطلع لنا من المايك تايم سيريز للسيرفس ليفل. انت عايز تعرف السيناريو مثلا بتاعنا هنا بعد 100 سنه الستورم هيبقى شكلها ايه؟ ففي حاجه اسمها اكستريم فاليو اناليسيس. ايه اكستريم فاليو اناليسيس؟ ده تول كده تدخله التايم سيريز يشوف هو الحاجات الكبيره ويتوقع، يعني يرسم ليه كبرت كان كده وكده كده وكده كبيره كده، يتوقع بعد 50 سنه او 100 سنه بيسموها التيرن فاليو هيبقى الماكسيموم قد ايه. اوكي؟ فدلوقتي في جزئين في الموضوع، جزء راندوم وجزء ديترمينستيك. فالراندوم لما بيركب على الديترمينستيك وهم بيركبوا على بعض، ممكن الكبير بتاع ده يركب على الكبير بتاع ده، الماكسيموم مع الماكسيموم، وممكن يكون الماكسيموم على المينيموم، ما هي راندوم بقى. فاحنا عندنا ايشيو هنا، عندنا اشكاليه. لو انا عملت اناليسيس للتركيبه على بعضها هبقى مش قادر اعرف هو كان الكبير مع الكبير ولا الصغير مع الصغير ولا الكبير مع الصغير ولا. فهنا بيقول ايه؟ عمل حاجه هو في الاول علمنا اللي هي الدي كابلنج او دي تايب، سماها دي تايب. دي تايب يعني بيفك التايب، فهيعمل سبليتنج تايب على بعضها، هيعملها سبليتنج انتو تو كومبوننتس، واحده ديترمينستيك عارفه وواحده راندوم. فالديترمينستيك دي عارفينها خلاص فكيناها، هنمسك الراندوم نعمل لها اناليسيس، اكستريم فاليو اناليسيس. كده احنا عملنا ايه؟ اكستريم فاليو اناليسيس للراندوم الحقيقي. وبالتالي بقى معانا بعد 100 سنه لما نيجي نعمل اكستريم فاليو اناليسيس الكومبوننت راندوم نقدر نقول والله الراندوم دي هتوصل للارتفاع ده، هتوصل للارتفاع ده. اللي شايفين الحته الكبيره العاليه دي، يعني الحته العاليه دي فاحنا ابتدينا نفصل العالي عن نيجي بقى لما نيجي نركبه هنركبه بقى بمزاج. احنا دلوقتي عرفنا الاول كانوا مركبين هم على بعض، فانا ما اعرفش كبير جه مع الكبير ولا جه مع الصغير، لكن لما فكيت اصبح خلاص الراندوم معايا، عملت له اكستريم فاليو اناليسيس، عرفت لما اجي اركبه بقى على الديترمينستيك اروح اركبه على الكبير براحتي. خلاص انا عارف يعني دي الراندوم، والديترمينستيك معروف الكبير من الصغير بتاعه اللي هو الهات واللات، فاهمين؟ فانا اقدر امسك الراندوم واركبه على الهات واقول هو ده الاكستريم بتاعي الايه؟ فهمت الكونسبت ماشيه ايه الدسكشن؟ يعني
مش السيرش.
ها؟
السيرش راندوم هو مش السيرش.
الراندوم هو السيرش اللي جاي من الويند واللي جاي من الشويس. الريزيدو بيسموه ريزيدوال، بيسموه راندوم، بيسموه سيرش، هو ده. اوكي؟ انما الثاني طيب ده جاي من طيب الويف، طيب الاناليسيس. اوكي؟
عندي استاذ نقطة أخيرة وقالها ازاي بنعمل ريبورتنج للقيم النيجاتيف لوحديها والبوزيتيف لوحديها. النيجاتيف ده بينديكيت لي انا عارف البوزيتيف ده انا
الماكسيموم يعني. وانا اللي حسيته بس انا هسألك. اللي انا حسيته انت هتعمل اكستريم اناليسيس بنوعين، اكستريم للمينيمم واكستريم للماكسيموم.
المينيمم ده هعمل ايه؟
اوكي، يعني بيسالوا عن الجزئيه دي.
ممكن يكون حاجه في الفيديو عشان
قلت انا
ممكن يكون حاجه في المينيمم النيجاتيف على الوداد
على الانت
علات
لو هو عايز يعني يجيب المينيمم بتاعه هو على حسب انت عايز. هو في الاكستريم فاليو اناليسيس هو اكستريم، الاكستريم مش لازم يكون ماكسيمم بس، يعني دايما في الاوبتمايزيشن بروبلم بيقول لك المينيمم او الماكسيمم. انت ايه اللي يوجعك؟ انت فاهم؟ اصل احيانا اللي يوجعك المينيمم. يعني مثلا لو انت خارج من البحيره تنشن انهي هو هتساله في ال
وشوف ليفر ده لوحده.
اوكي
بس السؤال تاني هو قال المينيمم هو
المينيمم
1 year التايم سيريز يعني اللي عندي منها بس في بس بتاعت التايم. رقعة تانية عندي بس يفضل إن هي تبقى 13 أو كذا. فرضنا كورس يعني مع حد كده
ده 4 سنين.
ساعات جرب أوقف فقال لي إن المينيمم
قال لي منهم 40. ايه اللي اجاوبك انا ولا انت؟
لا
مش اجاوبك. بص التايدال سايكل هي نتيجه حركه القمر حوالين الايه؟ الارض. ممكن واحد يبص ابسط حاجه هنبص ان التايدال سايكل دي حركه القمر حوالين الارض. هم 7 ايام بيبقوا نص قمر، وبعد كده بيبقى انتوا عارفين بيبقى قرص، وبعد كده ينزل نص، وبعد كده ينزل مفيش، وبعد كده يرجع نص، وبعد كده يرجع قمر. صح؟ حلو قوي قمر دي يعني عارف تخيل الواحد يفكر في حاجات تانية. فكر ايه المهم فهو مش فاهم والله، بس هيديك بترجمه كمان. فالسايكل دي قمر نص مفيش نص قمر قد ايه؟ 28 يوم. انت كده جبت لي 28 يوم، واحد يجي يقول لك اديك 14. اصل قمر نص مفيش نص، ما انا لو جبت يعني جبت قمر مفيش نص، انا جبت نص جبت والثانيه زي كده. فلما نيجي نعمل تايدال ميجرمنتس او اي حاجه 14 يوم، يبقى انت جبت لي يعني ايه مليون سنه، يعني دوره كده. اوكي، فممكن نطلب 14 يوم. هنطبق شويه 28 يوم. ده انت كده يا دوب على اللي انت بتبص عليه من الارض كده من تحت. تعالى بقى خد عندك ان الارض وهي بتتحرك خلال لفتها حوالين الشمس، واخد بالك، وضع القمر بالنسبه للنقط اللي على الارض. يعني القمر كان فوق القاهره، طبعا القمر ممكن يبقى معانا هنا بس القمر كان فوق القاهره. بعد شويه القمر بقى فوق، هو يلف، فهو اللوكيشن بتاع القمر بالنسبه للشمس، ما هو في قمر وفي شمس، بيتغيروا. فالكونتريبيوشن بتاع الارض القمر هما الاثنين بيشدوا الميه، واخد بالك، ده بيشد وده بيشد، الاثنين بيشدوا في نفس اليوم. ما بيتكررش على مستوى السنه، ما بيتكررش البوزيشن بتاع الارض والشمس زي بعض. انت فاهم؟ يعني اللوكيشن بتختلف. يبقى انت لو جبت لي سنه يعني يبقى ايه؟ يبقى انت حلو بقى، يعني قصدي خويت. باقي له حاجه ثانيه بقى. فاكر البلان اللي هو كان عامل تايدل ده كده قاعد يكسريت، قال لك بيكسريت في 5 درجات. لقيوا ان القمر كمان وهو بيلف مش محافظ على الاوربت بتاعه، ده الاوربت بتاعه يعني بالنسبه للارض احيانا يطلع البلان 5 درجات واحيانا ينزل 5 درجات. فقالوا طب هو بيلف ويرجع لللوكيشن بتاعه تاني امتى؟ لقوا 18.6 18.6 years. فدي بقى الايه؟ الفول هارمونيك اناليسيس. كل لوكيشن هو بيعمل حاجه اسمها هارمونيك اناليسيس. كل لوكيشن بيجيب فريكونسي معينه، ففي فريكونسي بتحصل كل 14 يوم، وفي فريكونسي ثانيه بتحصل كل 28 يوم، واكبر فريكونسي بتحصل كل 18 سنه 18 19 سنه. انت الليفل بتاع الكيوريوس بتاعك ماشي ايه؟ ففي لما يجي يعمل ميجرمنتس للاي دي سي كارنتس، عشان يقيس الكارنتس، الراجل معهوش فلوس يقيس 18 ولا 16 سنه. فانا بقول له ايه؟ لو الراجل عايز يمشي 14 يوم، اقل من 14 يوم ما ينفعش. انا قصدي يعني يشغلني مع بعض. في ناس كان عايز ينسوا الحاجه دي، انما 14 يوم ده البيسك. معاه فلوس شديد شويه 28. اوكي. دول بقى محترمه وحاطه بتاع ده جيج كلام من ده في المواني اديني يا عم ده 18.6. اوكي كده انت جبت سؤال انت قلته هو اللي كان المينيمم ولا اوكي ناو Robin, are you available with us?
Yes.
Yes, okay. It's clear for us all now what is the details. However, we have a small question in the previous slide.
This one?
Yes, last point. The last point, you talked about positive and negative.
Yes.
We would like to understand what is the meaning of negative you mean, and what is the importance in the application correlated to this negative point analysis. Okay.
Mm-hmm. So, as I mentioned before, this is of importance in many fields of coastal engineering, but I would like to make use of the example of a harbor. So let's see that our engineers in the audience, they are involved in a project that entails the design of a harbor. Let's say a commercial harbor, where you are expecting big vessels to arrive to the place, right? So a harbor in a harbor for big vessels, things that you need to consider are, for example, you will need to dredge an access channel from intermediate water to the basin or to the quay where the vessel is going to be moored, because you need to live under keel clearance. So this is distance between the lowest part of the vessel and the seabed to have some water for the vessel to flow. And what happens that level is defined by the tide. If you are in the Mediterranean, for example, where you don't have tide, you don't have to worry about this. I mean, the difference in the tide is is a few centimeters. But for example, if you are designing a harbor in where I come from northern Spain, where the tidal range, the tide goes up and down. So the distance between the highest water level and the lowest water level is 4 meters. You can think that 4 meters make the difference for the vessel. It is not the same that, let's say that my harbor is in 10 meters of water depth. But then if we add on top the progression of the tide, it can be that the local water depth is as high as 12 meters, but it can also be as low as 8 meters when we add the tide. And what happens that if let's say that we've got a vessel that it's a big vessel carrying, I don't know, containers, and that vessel has a draft of, let's say, 8 meters, right? So that means that it needs 8 meters between the water line and the lowest part of the vessel. You need all that distance of water, and still you have under the keel 2 meters of water depth. Now, if you design your harbor without paying attention to the water levels, especially to the negative water levels, it may be that when that vessel that needs 8 meters of water depth and is entering an area that has, without the tide, 10 meters of water depth, you may think, wow, my vessel has 8 meters draft, we've got 10 meters of water depth, the vessel can navigate without any problem because you still have 2 meters of water below the keel and the seabed. But what happens when the tide goes down meters? How much under keel clearance will that vessel have? 0, meaning that the vessel will get stuck in there. So you need to consider, you need to be aware, you need to calculate how low can the water level go down. Likewise, for the same example of a harbor, in a harbor you need to design the quays. You need to design the elevation of yes, or the platform where the vessel is going to be moored. And those platforms, they are looking for not to be reached or hit by any waves. So you need to make the levels of those keys as high as possible for the waves not to hit the deck level. And for that, you know that the more water depth that you've got, the higher the waves that you can have in there. So in that case, for the design of the level of the key or the deck, you need to know how high the level of water can reach, which is the combination of the tidal component, but also the residual component. And you say, okay, so now I am in an area where I have tides of 2 meters up and down the mean sea level. And after my extremes analysis of the surge component, it can be that in 100 years, I can get a surge of 1 meter. So the engineer would say, right, at this location, the tide, only the tide can go as high as 2 meters above the mean sea level. But on top of that, it may be that I am so unlucky that at the moment that I am getting my highest tidal level, I get the worst storm in 100 years. And I have to put on top of that tidal level the contribution of the surge. And let's say that surge can reach the 100-year return level surge is 1 meter. That means that the water level in that situation, measured from the mean sea level, will reach 2 meters of the tidal contribution plus 1 meter of the surge. So, meaning that from the mean sea level up to the top of the water level, we will have 3 meters of water. Knowing that, you can say, okay, in the worst case scenario in 100 years, I may have 3 meters of water above the mean sea level. Knowing this, I can design my deck level to be at least, let's say, 3.5 meters or even 4 meters, and then I ensure that the water level does not reach the deck. So that's the reason why you need to perform the analysis on both water levels or surges above the mean sea level, but also below the mean sea level. Below the mean sea level is because it's going to drive or it's going to tell you the type of vessels that you can have in your harbor. And the higher water levels will tell you the level of the decks, the level of the keys that you need in order not to be flooded by the water level. I can tell you many other examples of where the positive and negative water levels are needed, but I think that this one is the clearest and the easiest to get. Am I right, or do I need another example?
Okay. Yeah, it's great.
It's good? Good. So very quickly, what's the sequence to perform an extreme value analysis on water levels? So I would say this sequence is valid for both, as I said, if you consider the total water level or if you split it in two and then you keep the surge component. It works the same way. The first step, I would say, take your time series of either total water levels or residuals and split it in 2 time series. One with all the levels above 0 and another one with all the levels below 0. Once you've got those 2 time series, the following step is just performing the usual extreme value analysis. So applying to those time series a Weibull or a Gumbel or a Pareto distribution, whichever you want. And then also making use of different clustering methods, peaks over threshold, block maxima, wherever you have done and you have learned about how to analyze wave heights in the previous lectures is applicable in this step here. The following one, this is a heads up. When you are dealing with the negative values, it is advisable to negate the values. So this is turn them positive. Then perform the analysis. And once you have performed the analysis, to those results, change the signature again. Can anybody tell me what's the logic behind this? Or has anybody done this before and knows why I'm saying this?
Please, can you give more focus on the question? You
Yes.
mean by this you speak about?
So let's say that we've got my time series of negative values. So all the water, how low the water level can get below the mean sea level. I'm talking just about the residual component, not the type. So just let's say that I have my time series of negative values of search, and that let's say that the minimum value is minus 4 meters from the mean sea level, and the maximum value can be minus, let's say, just to have a round number, minus 1 meter. Okay, so now let's say that I have applied to my time series of negative search values a peaks over threshold clustering method, and I have ended up with, let's say, 5 values. Okay, and those values are minus 1 meter, minus 2 meter, minus 3 meter, minus 4 meter, and minus 5 meter. Good. So now the thing is that if you take those values as they are, minus 1, minus 2, minus 3, minus 4, and minus 5, let's say that those 5 values have been taken out from, let's say, from 50 years of data. Okay? I'm asking, can you give me a silly number? It doesn't have to be meaningful, but consistent with the data that I gave you, minus 1, minus 2, minus 3, minus 4, and minus 5. Can you give me an estimate of the 100-year return period value of the search? In 50 years, the minimum that we got was minus 5. So what can I expect in 100 years? Just say a number, but something that is consistent with those values. Doesn't matter.
السؤال
يعني هو عاوز ايه اللي بين النيجاتيف والبوزيتيف.
هنحاول السؤال التاني دلوقتي يعني حاول تجس لو هي ناقص 5 negative 5 in 50 years what will be after 100 years negative 1 negative يعني كام negative 1 you have 3 negative 4 negative 5 after 50 years it will be negative 5 after 100 years it will be negative what's the value?
So will it be less than minus 5 or more than minus 5?
هو اقل من 5 ولا اكثر من ناقص 5؟
هو هنا اكستريم هو ملهاش قيمه ملهاش على دي لمبه زيرو. وشغال على التايب بعرف يعني ان انا هنا انا شغال على اكستريم البوزيتيف. البوزيتيف المتحكم في معلومه السحابيه هو ماشي.
نعم
لا يعني
يعني
انا مثلا التايب كل ما بيعلى مع بوينت يشكل نيجاتيف.
هو السؤال لو هي نيجاتيف 5 بعد 50 سنه.
So let me rephrase it to make it more simple. Let's say that in 50 years of data, the lowest values by means of the peaks over threshold method that we got were minus 1, minus 2, minus 3, minus 4, and minus 5 in 50 years of data. So in those 50 years of data, the minimum value that we got for the search was what? Minus 5, right? That's a minimum. Between minus 1, minus 2, minus 3, minus 4, and minus 5 is minus 5. So what should we expect in 100 years? Something less than minus 5 or something more than minus 5?
Theoretically لو انا بعمل ماينس هيزيد لان هو بيشتغل على ماينس يعني طبيعي انه يزيد.
Great.
فوكس على البلد اسمه يقدر يعمل
Oh, come on, guys! It's not rocket science. It should be easy to.
بعدين سنة تبقى أعلى. تبقى ماينس تبقى ماينس 25 بس بعدين سنة تبقى ماينس.
One of the answers is negative 10.
Negative 10. So that's correct. So that's correct. I mean, we don't know if it's minus 10, but it could be minus 7, but for sure, less than minus 5.
I would like to suggest another answer.
Uh-huh.
Minus 9.
Minus 9. It works as well. It's just that that value is
Because-
consistent. So in 50 years, the minimum value that we got was minus 5. So we should expect that in 100 years, we should go even lower than that.
Yes.
But what happens if you pass to the fitting process of the data values like minus 1, minus 2, minus 3, minus 4, and minus 5? Which value is higher in this sequence, minus 1 or minus 5?
minus 1.
Minus 1.
Higher, mathematically.
So the thing is that because they are negative values, minus 1 is bigger or is more than minus 5. So if you try to fit your distribution, Gamble, Bible, Pareto, whichever, with the negative values, you will get a wrong fit because it will consider the minus 1 as the highest water level. And the fitting doesn't understand about that. So what you will get for 100-year return period or 200-year return period will be a value like minus 0.5 or minus 0.1 or even plus 0.5, which is completely wrong because you should be expecting even less than minus 5. So that's the reason why you take your data, you make it positive, and then the values will be, the 5 will be bigger than 1. And then the projection for 100 years or 200 years or whichever will be bigger than that 5. Let's say plus 9 or plus 10, whichever value. Once you've got those values, you then negate or you change the signature again, and instead of having plus 9, you will have minus 9, which is what Dr. Samir, the value that Dr. Samir was suggesting. But that would be a right value. Is it clear now? Why do you see that?
الموضوع ايه يعني قلنا اوكي الموضوع مرتبط بكلمه ماكسيمم ومينيمم. فانت علشان تقلب انت بتدور على السالب، يعني بتدور على حاجه بالنيجاتيف، فقلبها بوزيتيف اضرب في نيجاتيف 1 كده بتدور على الماكسيمم. فالايفا اكستريم فاليو اناليسيس looking for the maximum. The codes of EVA هو بيدور على الماكسيمم. فحضرتك عايز تدور على المينيمم تعمل ايه؟ قبل ما تدخل ده ضرب بسيط نيجاتيف 1. فانت لما ضربتها في سالب 1 راح عملت ايه؟ قلبت المينيمم ماكسيمم والماكسيمم مينيمم. Did you catch the point؟
بعد ما نطلع الاول بص
وبعد ما طلعت الاوت كنت اديلها تاني. عندنا مكسر ولسه مصاب.
بس يعني هو المفروض يعني هو بيضرب مثلا كده بالارقام ده اللي حصل معاه فعلا في الدراسه على 50 سنه. اصل المفترض حضرتك بتقول ان الدراسه الاول هنا 18 سنه وست.
لا احنا ما بنتكلمش على التايجر. بنتكلم على الستورم اللي هي بتاعت العنكبيه الرنر. التايجر
هو مش واخد بيست كلها، ده بيتكلم مثلا على اكستريم فاليو بس.
بص احنا الاول قلنا عندنا سيرفيس ليفل اليفيشن توتال،
تمام،
قسمناه تايجر
باينه وده ثابت
وراندم.
والراندم اللي هو
التايجر ما تبصلوش لان انا اقدر اجيب لك الهات واللات والاكس.
هو راندم يعني. طب ليه احنا واخدين من الماكسيمم والمينيمم الاثنين لازم يكونوا قد بعض؟
لا مش قد بعض.
طيب
احنا قلنا عايزين نجيب الماكسيمم الايفا فور ماكسيمم والايفا فور مينيمم. وانت بتجيب الايفا فور مينيمم اضرب في السالب 1. لا انت هتشتغل مرتين، مره على الماكسيمم ودي زي ما هي. اوكي؟ بعد كده انت عايز تجيب المينيمم وهو مش قد الماكسيمم. تجيبه ازاي؟ اقلب الداتا.
حط نفسك في الامان يعني.
اقلب الداتا كلها. وبعد كده اعمل الاناليسيس بتاعك. يبقى انت جبت المقلوب. بعد كده اعدله تاني. Okay, now it's very clear for all of us.
Fantastic. Good. So the only hint or advice that I have to say is that if instead of sea surface elevation values, you are dealing with current values, it does not make any sense to split the analysis in positive values and negative values. I mean, your current may have a negative signature, but just because it's telling you the direction where it's going. But the module cannot be negative itself. I mean, you cannot have currents of -2 meters unless you are saying that -2 means that it's going in direction wherever. So bottom line, when you are dealing with the same analysis, but with the values of the current, you don't have to split it in positive and negative. You just take all the data, because it will be positive, all of them, and apply the analysis. And then that's it. This one was an easy one. So let's go for the following, for the next slide. I hope that you can see it properly on the screen. Something happened to my screen. Can you see the slide?
It is very small.
It's very small.
There are
So let's see.
two slides.
Yes. So that's the thing. How can I? Because I changed the screen.
Yes.
Maybe. Can you see this one? Big?
Yes. Now it's great.
Okay, fantastic. So in this slide, what I'm showing you is for a project at a certain location that we did here in Nires. Is I'm showing you the results of the analysis that I performed on total water levels. So I had a hydrodynamic model with Mike, and at a certain location, I output a DFS0 file. And that DFS0 file had the variable sea surface elevation, referred to the mean sea level. And then what did I do? So I took those time series and I applied a detiding analysis. So from the total water level, because I was forcing my model with both tidal boundary conditions and also atmospheric conditions, wind and air pressure. So my output signal from Mike is total water level, including tides and meteorological component. So then what I did is, okay, I'm going to take this time series at this location and I'm going to split it in tidal and residual by making use of the UTide tool. Good. So when I decomposed those two time series, I was able to first construct the table in the middle that you see here, which is based only in the tidal information or the tidal description that I got as output from UTide. I am able to tell you for that location what the highest astronomical water level will be with regards to the mean water level and the lowest water level that I can get, just because of the motion of the planets. Nothing to do with the weather, nothing to do with the search, nothing to do with air pressure, nothing to do with wind fields, just with the motion of the planets. Now that I have that, I said, now I have, on my other hand, I have a time series of residual, a time series of search. Say, good. Now what I'm going to do is this time series of just residual data, I'm going to split it in two. I'm going to create one subset with all the values above 0, which is above the mean sea level, and then I will create another subset with all the values, all the negative values. These are the ones that are below the mean sea level. So these are those with negative values. And after that, I perform an analysis on each of the two subsets. So what you see on the screen is in here at the top is the result of my extreme value analysis to the subseries of positive values. So from those, from the time series of residuals that I split in negative and positive, I took the positives and then I applied the usual extreme value analysis, making tests on the sensitivity to a Weibull fit, to a Pareto fit, to a Gumbel fit, and also considering block maxima, annual maxima, monthly maxima, whatever. Things that you know already from previous lectures. So the result from that fitting process of the positive values can be seen in this plot in here. And the tabulated values for return periods of 1, 10, 5 that should be somewhere in here, 100 years in here, are shown in this table. And likewise, for the other subset, for the other sub-series that I created with the negative values, I repeated exactly the same type of analysis. The only thing that I did in the analysis was to change the signature of those negative values to positive. And then I got this plot. When I was creating this plot in the code, in my MATLAB code, I then, for plotting purposes, I changed the signature of the values again for you to see that the values are indeed growing negative more and more with the return period. And the tabulated values are shown in here. And then that's it. So this is a very good way of presenting water levels in your report. Because, for example, let's say that the engineer or the client is interested in knowing what's the worst thing that can happen in 100 years. And then you can say, okay, if you are going to design the deck level, so you're interested in seeing how high the water level can reach. So you can design your deck above that water level. So the water level does not go into the deck. And you say, good. So let's assume that this is telling me that the highest astronomical tide is 0.31 meters above the mean sea level. But beyond that, the highest still water level is 1.13 meters. So if I am putting myself in the worst case scenario, I am going to imagine that at the time that the 100 year search is happening, I am so unlucky that I am also getting the highest water level possible due to the tide only. So this means that I should design the height of my deck or the height of my key such that is above 1.13 plus 1.29. So that means that I should have a deck level of at least 2 meters 0.42 above the mean sea level. If I have something less than that, if my deck level is, for example, 2.3 meters above the mean sea level, that means that when this happens, if it gets to happen, the water will be flooding my deck, and then that will be a catastrophe. Likewise, for the design of the berthing pocket, so this is where the vessel is going to be moored along the quay. You need to have enough depth for the vessel to be in there. And let's say that I have a vessel that is, I'm going to expect vessels with a draft of let's say 3 meters. So 3 meters between the water line and the keel of the vessel. So I need 3 meters. This is telling me that in the worst case scenario in 100 years, my search can go as low as 0.87. But if I place myself in the worst case scenario, I can say this is going to be the doomsday. I'm going to have, or I want to see what happens if the lowest search that I can get in 100 years, which is minus 0.87, happens exactly at the same time that I am having a tidal elevation of minus 0.78. That means that from the mean sea level, in that 100-year event, my water level will go down 0.78 plus 0.87. And now my math is a bit like this, but it should be something like minus 1. Almost minus 1.7 meters. So I need to be aware when designing my berthing pocket or designing my access channel where the vessel is going to enter, that at least I'm going to lose in that event 1.7 meters of water depth. So better for me to design or to design a berthing pocket or an access canal that even in that case that I'm losing 1.7 meters of water, there is still enough water underneath to cover the 3 meters of the clearance of the vessel, plus a bit of room for the water to flow underneath and the vessel not to get stuck in the canal. But this is the worst case scenario, because then the engineer can say, okay, that's the worst case scenario. And now let's think of a less catastrophic scenario. Let's say that I'm interested in the 100-year event, which is, let's say that I'm focusing on the design of the deck. And I say, okay, in 100 years time, the worst storm that can happen is plus 1.29 meters above the mean sea level. But then instead of being so pessimistic and saying, this is going to happen exactly at the same time as this. I mean, this water level happens usually once every 20 years. So it will be extremely, extremely unlucky if this water level happens at the same time as this tidal level. So the engineer can say, okay, I'm going to use something that happens more often. For example, the mean high water springs is a value that happens on average every month or every 2 months. I can't remember right now. Let's say that it's every month. So let's think what would happen on an average case when this is happening. So that would say, okay, in an average case, I should expect the 100-year return period surge happening with, let's say, a high water level, which is not the most unlikely. So that would mean 1.29 plus, let's say, 0.25. So let's say if I design for plus 1.30, for 1.44 meters, that should be okay. So this is the flexibility that providing the tidal levels and the surge levels, both positive and negative, separately, that gives you a lot of power for your design. Because if you are providing with total water levels, if you don't do the detiding, although it is not incorrect, you will be being extremely catastrophic. You will be giving the worst of the worst scenarios that can happen. And in the one hand, it is nice to be in that, to bear those scenarios in mind, because you are designing for the sake of safety. You don't want to lose human lives. You don't want to lose buildings. You don't want to lose infrastructure. But it comes at a price. That if you want to design to withhold or to support, to withstand these events, you need to employ more material. You need to use more iron. You need to use more concrete. You need to use more manpower, and that translates into money. And it may be that if you want to design something to withstand the 100-year storm surge at the same time that the highest still water level happens, it may be that your budget to construct your harbor rockets by 1,000%, and you need $1,000 million more. And then the owner will say, sorry, I prefer to lose human lives than to spend $1,000 million. And unfortunately, this is how the world works. So you have to adapt, and you need a compromise between being safe enough but not putting yourself in the worst case scenario. Putting yourself in the worst case scenario is very good when you are at university, when you are at the school, when you're getting your degree, because it's theoretical. And if it's theoretical, it does not mean that you have to spend money. You have infinite money. But in the real world, you need to bear this in mind, that you cannot design something to be completely free of failure, or free of or without the chance of losing human lives. So this is the reason why it is more than advisable to perform an extreme value analysis of water levels this way. Split tidal component and residual component, then the residual component into positive and negative values, because you will use them for either one thing or the other. And with that information, then the engineers can start saying, okay, I'm going to play with these combinations and see which one gives me the worst case scenario, but it's still within the budget. And then we can create something. Because I'm not going to design something to withstand a water level of 5 meters, but that means that I have to spend 5,000 million euros in the harbor, which is unfeasible. Has this example been clear enough? I hope.
Yes, it's great. Just I would like to ask for zooming on the negative value
Yes.
logarithm. Yes. Just I would like to go to the yes. So
I cannot go more. I cannot go
yes,
more than
it's
this.
great. It's great. But here you didn't multiply by the negative value in this analysis. What about?
No, I mean, the fit itself inside the MATLAB routine that I have, the values were positive. But the thing is that when I was creating the plot, in order for me to have negative values in here, once I got the results, is when I changed. Once I had the fit and I had the results, is when for plotting only, when I changed the scale of the values for you to see that they are indeed going from minus 0.5 down to minus 95. As I said before, if I got to perform the analysis, not negating the values, so this is taking negative values, so passing the negative values as they were, the plot will be the opposite, meaning that with more return period, you are getting less water level, but higher water level instead of lower water level. Is this clear?
Yes.
Good.
طيب الداتا اللي هو التيبلز اللي موجوده دي بتتحسب لكل لوكيشن لكل منطقه معينه ولا غير؟
Excuse me.
البالانس دي
There are one question about the tidal level, which is the hat and lat and so on. What is the source of this data?
The source of this data. So this is these are the different tidal levels that are associated to the different tidal constituents. So for each part of the world, these values are different because the constituents are different, because this is not the same the coastline in Egypt than in Portugal or in Finland, and that has an influence on the tide, and that ends up having an impact on the constituents and so in the values. But basically, all of these values, you can find the definition in anywhere on the internet, what the mean high water springs are. So the mean high water springs are the average of the two consecutive peaks within the 15. I can't remember right now the exact words for it, but you can find these descriptions in NOAA, in ECNWF, everywhere. I mean, you just type tidal levels or high water level or highest astronomical tide, and you will get a description of what each of them is. But as I said before as well, in this paper that I'm writing in here, it describes the process of the harmonic analysis, how the mathematics behind having a total water level signal and then decomposing it in its tidal components. And in here, I will try to zoom in a bit if I can, if it lets me. That no, it's not letting me. Well, I don't know. It's not. Here we are. It's taken from that paper. The paper tells you the definition of what mean low water level is, mean high water is, mean high water springs, but it also tells you that once you have performed the analysis and you got the components, you can compute those values with those components, because M2 is an output from the U-tide analysis. S2 is an output. Knowing these numbers, you can easily calculate. And I have to tell you that these values are critical in any coastal engineering study that is not pre-feed level, but it's above that. You will be asked to provide these levels, because as I told you, these are crucial for the design of basically a harbor. That's the main thing. You need to know how low the water can get, and you need how high the water can get. Good. Fantastic.
Okay, great.
So yes, any questions?
Yes, please.
بما فيها حضرتك طبعا ندوع ولا النيجاتيف هتضاف على ذات بس والبوزيتيف على ايه؟
هو قال لك صح ان انت تضيف. The question is as follows. He is asking, after you got the storm extreme values after 100 years, you are going to add it to the hat or the for all values, which value?
So as I said before, you have the if you have the return periods for the search you know how or you can infer how the atmosphere, how severe the atmosphere is going to be in 100 years. But the tides are always going to be between a minimum value and a maximum value. And as I said before, it's up to you to say, I'm going to place myself in the worst case scenario, is when this horrible storm happens at the same time as the highest still water level, for example. Or it can be that this horrible storm happens. I am so lucky that by the time this storm arrives, it's when the tide is at its lowest. So it is not the same adding to this distance this on top that adding this surge here. Because as you can see, the total water level in this case would be like this, and in this case would be up in here. So that's the flexibility that is telling you that how can I explain it with other words? For example, let's say it this way: the tide has a period of 12 hours, and how many days does it take for the moon to go around the Earth? Does anybody know? How long does it take for the moon to complete an orbit around the Earth, more or less? 1 month, 28 days, right? That's the lunar thing. So basically, because the moon is the main driver of the tides, this is loosely telling you that every 28 days, at a certain location, you have repeated tides. So the cycle repeats again, and they get as high as they can and low as they can. And it repeats every month. This is not completely true, because if you go through an entire year, you will see that there are moments when the tide goes slightly a bit higher and slightly a bit lower. But in the overall, every single month, you repeat the cycle. So, and those values are between the HAT and the LAT. So meaning that any time in the month, you have the same probability of having mean high water springs than having mean high water neps, or having mean low water springs. But for example, the highest astronomical tide, that's when the sun and the moon are in a specific alignment with regards to the Earth, is when they get the highest. That's what is called highest astronomical tide. And that is something that happens basically on average once every 18.61 years. So if you have your residual return periods of 100 years, and you combine it with any of the likely values of the tide that you are going to see any other day that you go out to the harbor and try to measure the tide, 90% of the time, your tidal values will be between the HAT and the LAT. And all of those values of the tide are equally probable, because they will happen in a sequence. But if you are taking, for example, the highest astronomical tide level, I told you that is something that happens 18.61 once every 18.61 years on average. So if you are telling me that the 100-year return period surge is going to happen at the same time than the highest astronomical tide, what's the return period of that combined event? Is it 100 years? Is it more? Is it less?
More.
More. Why? Because this happens once every, let's make a round number instead of 18.61, because it's making me, let's say once every 20 years. So you are saying that, or you are looking for an event that happens. So this one that happens once every 100 years. So think of this as a timeline of 100 years. And this storm surge can happen at any time along that line. 1/100 years. And now you consider the tide, and you say, I want this to happen At the same time, now I'm creating a new lineup here for the tidal levels. And you are telling me that you want this event that happens once every 100 years happening at the same time of an event that happens on average once every 20 years. How unlucky you have to be for the event that happens on average randomly once every 100 years to happen exactly at the same time that the event with a return period of 1 every 20 years happens. So that's, for example, is you can compute the number thinking of dice. What's the probability? We have a dice with six faces. What's the probability of getting a number 5 when I toss it once?
1/6.
1/6. Okay, and now I'm telling you, what's the probability for me with the same dice to get a number 5 if I have had prior to this tossing of the dice, if prior to this toss I got a 5? What is the probability for me to get a 5 in the first roll of the dice and then followed by a number 6 of the same dice? What is the probability?
1/36.
Correct, because it's conditional probability. Yes, I need to have in the first roll the 5, and in the second one I need the 6. So that means that I have 1/36. What is more, 1/36 or 1/6?
1/6 is greater.
1/6. So what you are telling me is that when you combine the 100-year return period search with the highest astronomical tide, which happens more or less once every 20 years, you are not telling me an event that has on average a return period of 100 years. You are telling me that that is an event that happens 1/100 multiplied by 1/20. Or if you want to have the round number, let's put them invert. So 100 times 20. You are not giving me the 100-year return period event. You are calculating for the 2000-year event, which is way, way worse and way, way unlikely. Not that it cannot happen, but it is more than unlikely to happen. And if you want to design to that level, to that return period, then that's fine. If the regulation or the client says, I want to have a harbor that withstands an event that happens every 2000 years, fine. But you need to be aware that that thing that happens every 2000 years is way worse than what happens once every 100 years. And if you want to build something that withstands that, you need to spend much more money in engineering, in materials, and in people. And money is not infinite. And the client will tell you, yes, very nice, but I don't have $5,000 million in my pocket to construct this. So give me something that I can handle. So give me a realistic combination. It is understood now how the combination of tidal levels and search levels, and then how the return period works in these situations with conditional probability. Fantastic. So good. Having said this, I just have for this lesson just 2 quick slides, and then we are done. So the first one is sea level rise. So nowadays we are in this situation where everybody's talking about climate change, and everybody's talking about, for example, water from sea level rise. You know, the poles melting, the ice on the poles melting, and then the sea level going up. I will not go into detail and discussion on what we do believe about the climate change, if you take it or not, blah, blah. But I will tell you that this is something that is requested. And then, basically, for the sea level rise is a consideration or projections or estimates made by the International Panel for Climate Change, which is a body made out of many researchers from top institutions all over the world, and then they decide and do research on what could happen in the future, depending on different scenarios. For example, if we keep burning coal and burning gas as we are doing right now, or if we stop immediately and we rely on renewable energy and green energy, the scenarios will be different and the melting will be different, blah, blah, blah. So I think that information, you can find it in this link directly to the IPCC report. I am making, I'm presenting the relevant table here to the right. And here is the plot that is of interest for you, which is for different scenarios. It tells you for the different years. So we have measurements from 1950 up till 2020. And this is when the plot starts to diverge. So in here we have sea level rise, and here we have time. So we can see that beyond 2020, there are different lines. Yes?
Zoom in.
Oh, yes. Sorry, my bad. Here. And now we need to do, yes. Okay. Can you see now?
But remove the circle.
Remove the circle. Yes. So if I do this and then, can you see now?
Yes.
This plot. Good. So then you see this report was released in 2020. So the thing is that in here we can see that the water levels, globally speaking, in the world are steadily increasing based on measurements, based on what we have experienced in life. And then from 2020, you see that this line diverges and you have different scenarios. So in here, you have the different scenarios, SSP 1.9, SSP 2.6. All of these scenarios are different scenarios on, as I told you before, if we are going to keep burning coal, if we're going to keep burning using nuclear power, renewable energies, blah, blah, blah. And depending on how much or how good or how bad we are doing, we will be melting, the temperature of the planet will be increasing more or less, and then you will be getting more or less sea level rise. So meaning that at this constant sea level rise trend, depending on the scenario, you may have different sea level rises. For example, let's say that for the year 2100, if we pay attention, or we assume that from now on we are going to behave like proper human beings, and we are going to be considerate to the planet, and we are not going to burn coal, and we are not going to use nuclear, and we're not going to use gas. We are only going to use green power. It may be that the water levels are going to increase up to 0.5 meter from now. So let's say, for example, you are in Cairo. Now you have a certain water level, meaning that in the year 2100, you should expect a water level 0.5 meter larger. If we are in this nice scenario of stopping burning coal and burning gas and oil. But if we say, or we consider that we are going to keep burning gas, and we are going to keep burning oil, and that we are going to I don't know, to throw nuclear bombs and increase artificially the temperature of the planet even more, we may that sea level rise will be faster and higher, meaning that for the same year 2100, instead of having in El Cairo 0.5 meter more of water level that we've got that we should expect, we will have double. We will have 1 meter. So then this is up to you. It's up to the engineer in discussion with the client to agree in which scenario we should pay attention to, and then take that projection for whichever period you are designing. Let's say your client says, okay, I want to construct a harbor, and I want to start exploiting it in the year 2050. And the design life of that harbor is 50 years, so it should be operative until year 2100. Then you need to say, okay, apart from all the extremes, the nice extremes that I have provided you with, we need to take into account the sea level rise, because each year the water level will be increasing a few millimeters, but after many years, those millimeters will become in the order of meters. And then you can say, okay, so for the year 2100, to the water levels that we have designed, you should increase your water levels by 0.5 meter if we are considering this scenario, the nice scenario when we go green. But you also need to consider what happens if we do the opposite, if we go evil and we start burning all the resources of the earth and we start nuking every single country and increasing the planet temperature and melting the ice. And then we will go into a way worse scenario. And those considerations, you present them in the report and say, oh, and the client can say, oh, okay. And then design according to that sea level rise. Having said this, well, this is what I've been telling you. For example, I'm going back to this plot. Here's the AB1 scenario. I think here. I'm giving you an example. If you follow this link, this will take you to the IPCC report, where you have the different projections and the different ratios of increasing sea level per year. And it's telling you, in one of the most, in the mildest scenarios, in the ones that we go green, that we don't burn a lot of coal and we don't use nuclear bombs or whatever, it says that from now on, you should consider a steady increase of 4 millimeters per year. So meaning that, for example, in the year 2100, from now, you should expect 0.304 meters more of water level than we have now. And that increase in water level is not due to the tide. It's not due to the planet motions. It is not due to the surge. It is due to the melting of the poles and that water increasing the water level. So that's, let's say, we can call it as a third component of the water level. One is the tide, one is the surge, and I'm not saying this officially, but for us to understand, the third component would be the sea level rise. And that's how you define, design your infrastructures for the future, taking into account the sea level rise. Is this clear?
Yes.
Fantastic. So then we only have the last slide. Detrending. So what is this? Detrending. So depending on the nature of the data that you are handling, let's say that somebody gives you for your project a time series of water levels, of total water levels. They can come from either a model, like a massive Mike 21 FM model, or a climate model run by ECMWF, where they have started running the model, I don't know, in the year 1930, and they have been allowing or simulating as well the melting of the poles. So the sea level rise in each simulation is being taken into account. So in your output time series, the annual increase in sea level rise is taken into account. Or instead of making use of model time series, let's say that you get 40 years of measurements from a tidal gauge from a harbor nearby your location. And when you analyze that data, you will see that you can see, it's not always the case, but you may see that every year that passes, apart from the typical oscillations of the high tide and low tide and the surge, you see that the time series somehow goes kind of on a ladder fashion. It goes up, 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 up. And what's the problem with that? Is that, remember, if you have a time series and you want to decompose it in the residual and the tidal component, for the tidal component, based on the motions of the planets, that we know those equations and how they move because we know the paths and we know the elevations, the analysis will try to, from the signal that you've got, from the time series that you've got, will try to fit those planetary motions and give you the components. But what happens? That apart from the apart from the residual component, you have included in your series already the sea level rise. If you don't remove the sea level rise from your signal, Your total water level, the one in which you are going to perform your detiding, and remember the detiding process is from the total series, you get the tidal component and the residual component. But if your total water level series has included the sea level rise, now we don't have only two components in the time series. We have three, because the sea level rise is in there. But what's the problem? That the detiding analysis or the detiding software only considers or thinks of two, only residual and only tidal. So when it does the split, whatever is not residual is considered tidal. And what happens with that? That then the program will incorrectly compute both the residual part and the tidal part. So first of all, you need to detrend that sea level rise from the time series. I am writing in here how to perform the detrending, but before reading that part, I want to show you this. The picture to the right, to the left, is a time series of measurements of sea surface elevation in a location in Germany. And as you can see that between the year 1850, when they started measuring the levels, up to present, you can see the oscillations going up and down, up and down. This is what we would expect from the tide, and also with a bit of contribution of the storm surge. But there is a clear trend in the water level from 1850 to present that it's going up. So if you perform your detiding analysis on this time series as they are, I told you the software considers only things that there are only two possible components, tidal and residual. What is not tidal is going to be residual. But in here is embedded the sea level rise. And UTide does not know that. So it will take the sea level rise as part of the component of the tide or part of the component of the residual, meaning that the outcome of your analysis will be incorrect. That's why prior to doing the detiding analysis, you should perform a detrending. And in the plot to the right, I'm showing you this example. So basically, in the picture to the right, the blue line is basically the same line as in here. More or less, it's just assuming, but it's for you to see what happens. And you can see, this is the original data, and you can see the trend. If you do the detrending to this time series, you will end up with the line in green, which is basically, you can see that all the peaks and all and all the ups and downs are exactly the same. They're in the same position, but instead of now having that slope that is telling you that the sea level is increasing from 1850 till present, it is non-existent anymore. Now everything is centered along the mean sea level. I haven't produced I haven't plotted the red line for this green curve, but if I plot it, now the red line will be a straight horizontal line. And now that you have this signal that you have detrended, now you know that if you apply the tidal analysis to this signal, you will get the right tidal component and the right residual component without the hassle and the spurious effect of having the sea level rise in it. And this is what takes us back to the previous slide, what I'm telling you how to perform the detrending analysis. There are two ways of doing this. The one that is the simplest one is, let's say you have your time series of data that also includes this sea level rise, so you can see a trend. Let's say that you have 20 years, right? So what you have to do to detrend is you take every single year in those time series. For each of those years, you compute the mean sea level, which is just the average of all the ups and downs for that year, and you subtract that number from that year. And you repeat exactly the same for each other year in your time series until you cover the 20 years. Once you have done that, The resulting time series will be a detrended time series. And then you can perform your detiding analysis and your extreme value analysis, as I have instructed you to do in the previous slides. And the second way of doing that is slightly different, but it's basically the same thing, just a bit more elaborated. Instead of removing the mean for each year, you take all your time series, making sure that you have at least 18.61 years. You compute the full mean for those 18.61 years, or if you have 20 years of data, from those 20 years, you subtract it from the entire time series, and that's it, your detrended time series. As simple as that. So that was all. So I was supposed to spend 1 hour, and I ended up spending 2. So I hope that you don't want to kill me because it's stealing time of your life. So sorry about that.
No,
My pleasure. So if you have any other questions,
relation between search values والweb setup.
relation between
search اللي هو السيت
ايوه
السيت ده انكلود السيرش بس ولا مع الويب سيت اب؟ يعني بتتعامل ازاي مع الويب سيت اب والسيرش؟
I see. There are one question about what is component of the wave setup and the serve or residual.
repeat, please.
The residual
Mhm.
contains or not the wave setup.
That's the thing. If you are running the, we will focus on in just Mike because this is what it's all about. Let's say that you have your hydrodynamic model in Mike, and you only have the hydrodynamic model. You haven't run the wave model. You only have hydrodynamic. If you only have the hydrodynamic model, that model, the equations embedded in Mike 21 FM HD do not consider the wave setup because it's a hydrodynamic model. The wave setup is calculated by the spectral wave module of Mike. So if you are only making use of data, of output data from the Mike HD model, you don't have the wave setup. Only if you have run the Mike SW model, computed the wave setup or the wave radiation stresses, and then pass that information as input to your Mike HD model, in that case, the Mike HD model will take those radiation stresses, which have information about the wave setup and set down, will pass it in the computations, and your results will include the wave setup. But only if you have run the SW model first and you pass that information to the HD. Otherwise, the Mike HD module is just about hydrodynamics. It does not consider any type of wind waves. And since it doesn't consider any type of wind waves, it doesn't know anything about the wave setup. So the wave setup, you either pass it to it or don't consider it. Is this understood?
بس انا برضه مش متخيل شكلها يعني كان الفيجن فورمينج السيت اب از ريل داتا او الفيجن طب بجيب داتا مثلا من ايه؟ والسيت اب داتا ازاي في الموضوع ده؟
If the data source is not Mike modeling results and it is mainly measurements.
Oh, if it's measurements, then it is more than likely that you have, but remember the wave setup and the wave set down are non-negligible, or let's say they are meaningful in shallow water within the breaking zone, because the wave setup and the wave set down happens in the breaking zone. The wave set down happens right before the wave breaks, and the wave setup happens right after the wave has broken. So it is only relevant in the breaking zone, and the breaking zone is usually in shallow water or very shallow water. So if you are interested in a point that is outside of the breaking zone, let's say in intermediate waters or where you don't have wave breaking, you don't have to worry. But if your measurements are within the breaking zone and you are going to design something for the breaking zone, then the wave setup will be embedded in the measurements themselves. And then that is, in order to process and get rid of that from the time series, is a way more complicated process that goes beyond the scope of this lecture, and also not but close goes beyond my capabilities. I have done that before, but it's a pain in the back. So if you can avoid that, much better. But usually where you have I have to tell you, where if you go to a harbor, whenever you are going on holiday, or if you live next to the seaside or next to the harbor, and you go to a place where there is a tidal gauge, you will see that that tidal gauge usually is in a place where waves are not breaking. You have enough water depth for the tide to go up and down. Usually those are those tidal gauges are within a shelter area, let's say inside a harbor or inside a bay where the waves are more difficult to enter. So those measurement or those devices are placed in locations where usually wave breaking does not happen. I am not saying that it is not happening and that there cannot be wave gauges where breaking happens, but that usually that would mean that you are in shallow water, and then what's the point of having measurements of the tide in there when you are contaminating, let's say this way, the measurements of the tidal level with wave breaking that you're not interested in. You want to see just how the tide goes up and down, and for that you place the measuring device in an area where you don't have wave breaking. But I mean, there is bad practice all over the world, and sometimes you will find these devices in areas where there is wave breaking. But as a rule of thumb, and it should be, those measuring devices shouldn't be placed in areas where you have wave breaking.
By the way, the shallow water constituents is what is the forcing term of these constituents?
What do you mean with shallow water constituent?
In the tidal wave and in the tidal water analysis, there are two types of constituents. One of them related to the shallow area.
Yes. So the thing is that I mean, I haven't explained this in my slides, but at the very beginning, I told you that so basically the tides are controlled, let's say, by the moon, basically by the motion of the moon around the Earth, and then that pulls and compresses the water on Earth. The thing is that if we are in the middle of the Atlantic, where we've got water depths of 10 kilometers, the tide, I mean, the up and down of the sea surface elevation is basically controlled by the moon and nothing else. Wherever the moon pulls the water, the sea surface will follow. But as we are getting close to the continents, to the countries, the water depth diminishes. You're getting to the continental shelf, so the water depth has to diminish. But also, let's think, for example, of the North Sea. So you have Norway on one side, you have UK on the other side, and water can enter in that area, both from that area between Scotland and Norway, but also you can have water entering through the English Channel, right? So what happens that when the tide from the middle of the Atlantic starts entering into those areas, what happens that the tidal wave gets deformed. Why? Because it has to shrink, it has to accommodate to the boundaries of England and France, and it has to modify its shape. And the same happens for the water mass that is entering through Scotland. And that, what happens? Let's talk about simple physics. You have, let's say, a single wave, right? You have a sinusoidal function with an amplitude and a phase. The thing that you learn at high school in physics. But what happens when you start elongating or compressing that perfect sinusoidal shape? that imperfections and nonlinearities will start to happen. Right? And this is what we call in the tide subharmonics, meaning that, going back to the example of the planets, I told you that the tide follows the moon, but also the sun, and also the motion of Mars, and also the motion of Venus, to a lesser extent than the moon, but they have an influence. So each of those planets have a constituent given by one of these sinusoidal shapes. When you put all of them together and you want to make them work together at the same time, and they are affected by the boundaries of the continents, the interaction of all of those components lead to new components, which are called subharmonics. And those are what they are called the shallow water constituents, because those are constituents that they don't originate from the motions of the moon, the sun, and the earth, but they originate from the interaction of the tide with the boundaries of the continents and the water depth. Those are the shallow water components of the tide. And also, these programs, because they are based on latitudes and longitudes, they can compute to some extent the appearance of those subharmonics or shallow water constituents.
Okay, great. Is there any other question? Okay. Okay, thank you for this great information, and we enjoyed your lecture a lot.
My pleasure. So the thing is that now I don't think that we will go through the land use map today, I guess.
Yes.
So we will leave it for another session. It is ready, so whenever you want it, we will have it. Fantastic.
Thank you very much.
Have a nice evening, guys. See
Thank
you.
you.
Bye.
باي باي باي. ناخد بريك نصلي العصر. انتوا ساعة نفس حقيقي. خلاص نكمل من غير بريك.
نكمل جوه صوت كده جوه.
دكتور ابراهيم are available.
هو لسه نمشي.
لا لا عادي.
حاول امشي.
بس
السلام عليكم. دكتور سمير.
دكتور ابراهيم انا خلاص حبت كده. اسمها ايه دي؟ اسمها ايه دي؟ اللي هي الحاجات اللي
دكتور انا جايب نفس النهارده
بقى
تحسوا
والله
كلهم نفسه. انا عايز اكمل.
صلوا العصر الاول بس يا دكتور سمير.
هنصلي مش
احنا
استغفر الله العظيم. استغفر الله العظيم يا دكتور، مش عايز كده صلاه. لا هي عامة علشان بس نبقى ايه يعني، هو الحقيقة ثانية واحدة، احنا ممكن نتكلم في المشروع بتاع الدريكتور. البريس كويس قوي يعني. هي الفكره بس عشان نبقى شعب في الكلوزنج بتاعنا، يعني قصدك سوري.
ما هو البريك اللي ضاف علينا البريك اللي ضاف علينا في النص هو دوت.
عشان كده في مستوى الجوش. احنا كاسب من بكره بس.
في سندوتشات؟
لا
نجيب
برضه
كده دكتور ابراهيم. يعني احنا كده خلصنا الحمد لله النهارده، و يعني ان شاء الله الاسبوع الجاي لو هنكمل ان شاء الله. حضرتك ممكن تعمل
بريف او كلوزنج للسيشن.
بالتوفيق ان شاء الله يا دكتور سمير، وشاكرين جدا، وشاكرين للبي ام يو، شاكرين لحضراتكم جميعا، وربنا يوفقكم ان شاء الله. شكرا جزيلا يا جماعه. مع سلامه الله. مع السلامه.
مع السلامه.
مع السلامه يا دكتور سمير.
مع السلامه دكتور ابراهيم، مع الف سلامه.
مع السلامه. مع السلامه.
تصدقني انا كنت احسب نقص ساعه؟ يعني حقيقي كنت احسب كده يعني. فانت عارفين فهمت الساعه. اصل الكمبيوتر بتاعي ده احيانا كانت الساعه بتاعته مش مظبوطه، فبقى متصور ان هو